three other judges who are on the way. We have some of you probably met him, James Robinson from Geico. You guys probably met him at Hack AI. We have Dr. Sheen Levine. He's from the JSON School, and he's going to be teaching next semester a course focusing on the intersection of artificial intelligence and cybersecurity. So that's going to be pretty interesting. So we'll talk about that a little bit, and feel free to sign up for that course. And then we also have Babar Bhatti, co-founder of Dallas AI, and he'll be coming. But some of the judges are just running a little bit late, probably because of the weather. So we're having to push the start back a little bit. So sorry for that inconvenience, but we'll try to get started as soon as we have like three of the judges here. So thank you guys. Just feel free to like socialize, relax. You guys are going to do great. Great faith in all of you.
Yeah, you can get it.
Did you get it figured out?
Okay, now you can
No. Wait, okay.
Okay, I already went live.
It already did?
I already went live. Why should I not? Oh, it is what it is.
So when you first started,
So what do I do?
stop it.
You already started it? You have to make it, and then you have to resend the link to the.
I got you charged.
we get a drum roll real quick? All right, welcome everybody. Thank you guys for coming out. If you're not presenting, it means a lot to all of the people who have put all of their time, effort, and energy into doing this for this whole semester. So it means a lot. So thank you guys. Shout out to our judges. You guys already got to meet Dr. Tian, but real quick, if you could stand up, we got James here, recruiter from Geico, awesome guy, and he's a team dude. So feel free to get to meet him and talk to him. So just our agenda today, we're going to have some opening remarks where we're going to get to meet all of the mentors and meet the judges as well. And then we'll get into the presentations and then we'll have our closing remarks.
So just speak loud.
Okay, sorry. All right, so opening remarks. So just real quick, an introduction to the people who aren't in AIM. What is AIM? So it's just a semester-long project where students who have all sorts of backgrounds, all sorts of majors, all sorts of levels of experience with AI are given the opportunity to pair up with a mentor. And
I figured out the issue.
okay, are given an opportunity to pair up with a mentor, and over the course of the semester, they work with that mentor in a team, usually of like 4 to 6 students, and they build a project. And usually we try to deploy it on the cloud. Doesn't always work, but we try. So we really just want to give an opportunity to people who don't have like a lot of AI experience on their resume to get that project that hopefully can land them an internship. So real quick, can I just have all the mentors come up real quick and introduce themselves? Can we get a round of applause for the mentors?
So name, major, and red flag.
Red flag.
Yep.
We're just going to record it. It's there. So,
And speak loudly into the mic. Name, major, and year. And some of y'all are really young.
Am I first? Oh, no. Wait, what am I saying? Name, major, red flag.
And your year. And a red flag, yeah.
My name is Raven. I'm a senior. My major red flag is it I have more than one flag? One flag? There you go. So my project is chess vision, and basically what we wanted to do is we wanted to make chess evaluation feasible for smaller like tournaments, because chessboards are very expensive, like the digitized ones, and they're like very expensive. We'll talk about it in our project, and we just wanted to digitize real boards and just evaluate positions from that.
My name is Dan Wen. I'm a computer engineering major. I'm a sophomore engineering. My red flag is having to be presenting when there's a severe thunderstorm warning. So my project is about basketball highlight classifier. So we attempt to classify basketball highlight. And our end goal is one day to make it like cutting the full game, so you don't have to cut the game manually and classify the ball for you using AI and big data.
I'm Nevin. I'm a computer science major, and my red flag is I like to watch movies on ×2 speed. Are we introducing our projects, or we're doing that later?
No, it's just for time's sake. Yeah.
Hello, my name is Dhruv. I'm a computer science major, and my red flag is that I don't use TikTok. I personally don't like that. I'm more like a real guy. So
Is that a green flag I hear?
I mean, yeah, I don't even have a TikTok account if you like this. I know. So yeah, I'm doing AI and ML stuff. I have done previous internships, and hopefully we are making a good project in tech and finance. So, yeah.
Hey everyone, I'm Bryant. I'm a software engineering major, and I'm a sophomore right now. And my red flag is that I don't like pickles on my Chick-fil-A chicken sandwich. So yeah.
Hi, I'm Daniel. I am a software engineer and I am a junior. My red flag is that I sometimes wear a fedora, and our project is Rusty Bricks.
Hello, my name is Purna, and I am a computer science major and psych minor, and I am a sophomore. And my red flag is I play Valorant.
Anusha and Rami, I don't think I transferred you guys slides over, so just go ahead.
Hi, I'm Anusha. I'm a comp sci major and I'm a junior. And my red flag is that I don't like tomatoes.
Hello, my name is Rami. I'm a senior computer science major. And my red flag is that I enjoy the sound of white noise.
Behind your face.
Oh, I'm not thinking too hard face also.
My name is Zane. I'm a sophomore in computer science, and my red flag is I wear pajamas to class and in public.
I'm a junior in Bachelor's of Software Engineering. My team was on emotion recognition from speech. My red targets are not gonna have for at least 44 months.
I'm Akin Sule. I'm a computer science major, and my red flags are I don't use social media.
Yeah, we'll have you stand the entire time like that. Like a bunch of dolls. Yeah, you can go back. Thank you.
Thank you to our wonderful mentors. And I don't have a slide up there, but if you are a spectator, my name is Eamon. I'm the director of our whole mentorship program. My red flag is probably being friends with Biggie. All right, and so real quick, I just want to introduce our judges. I'm going to introduce the two that aren't here but are on their way first, and then I'll let you guys just reintroduce yourselves real quick, just in case anyone wasn't in the room. But we have Dr. Sheen Levine on the way. He is a professor in the School of Business here, and next semester he's actually going to have a course that's discussing the intersection of AI and cybersecurity. So interesting stuff. I think it'll be through the business school, but he'll be here to talk about the details. But I think you can earn credit towards a certificate in entrepreneurship by taking that class. So if that's of interest to you, that might be a good class to take. And then the other person we have coming is Babar Bhatti, and he is a co-founder of Dallas AI, and I think he works right now at IBM doing AI stuff there. So he's a very interesting guy. He's on the way, and so hopefully those guys will get here soon. I know Dr. Levine won't be here till 6, but I think Bhatti will also be here around then. And then real quick, if you guys just want to reintroduce yourselves.
Sure. Good evening, everyone. My name is James, and my red flag is I can eat a whole dozen of Shipley donuts in one sitting. So I'm a recruiter for Geico. I've been there for 11 years. I'm really excited to be here. You all look really fantastic. I'm looking forward to seeing what you all are bringing. I am located in Houston, so I came up here a few nights ago. All the events were canceled except for this one, so I'm excited to be here.
Yeah, I'm ready to give my speech about my lab research, and I'm in ECSS building, and my office hour is Tuesday. So if you're interested in any of AI relevant research, you want to talk with me, feel free to find me in my office, and also feel free to email me if you are if you want to discuss with me about anything about the research, AI, other relevant stuff. And I just finished my PhD, and if you are interested in like graduate program, PhD program, anything, okay, just find me. Okay, thank you very much.
Thank you guys so much. And I think without further ado, we're going to get into the projects now. So I think Rami, your group is first. Feel free to come up, you guys. You guys are plugging in, right? Okay.
Join the stream, right?
Yeah.
Okay, perfect. So share your screen, and then whenever that happens, send something.
Does anyone have paper? For the judges real quick?
No, like loose, like, does everyone have a legal pad? No? I forgot mine. Any like loose paper, anything? Notebook paper is fine, yeah. Yeah, I want to. If you want, if you want to use Google Docs or something.
And then you also get I should measure this. And then there's a mic as well if you all want to pass it around.
Okay. Speak loud. Good luck. Thank you.
Okay.
Thanks.
All right. Good evening, everyone. I'm Anthony, and today we are presenting our project, ChatGTD. And we think you'll really like this project because it addresses some of the recent issues with advising and really just the lack of support that students are getting when they first enter into college as freshmen or as transfer students. So just to get started, I'm Anthony.
Hi, my name is Ari. My name is Rami. My name is Dylan. My name is Sean.
So, as everyone knows, a lot of incoming freshmen and current UTD students have a lot of questions about like courses and parking and all that. And most people, they email their advisor obviously because they don't know. And I'm sure y'all have all had questions that weren't addressed or answered by your advisor in time. And I'll tell you the reason why. Okay, so this is, as of February 2023, the current ratio of UTD students to advisors is 566 to 1. And the National Academic Advising Association recommends a ratio of 296 to 1, which is almost half the ratio of UTD. And the main issue with that is that a lot of questions that students have aren't always addressed on time.
A lot of the information is already available online on the FAQ websites and a lot of the other UTD related websites, but a lot of students find this really difficult to access and find it very hard to find exactly where they can get this information. So
we had to come up with a solution to this issue, and our solution was ChatGTD. By harnessing the power of generative AI, paired with voice screening data, we can create a customized chatbot that answers questions about UTD.
Here are the technologies we use to accomplish our goals. The ultimate goal of our model is to take a question about UTD and provide a correct and concise answer. A naive approach would just be to just ask the question to ChatGPT. However, ChatGPT lacks context about our school to accurately answer the question. Although ChatGPT was trained on the entire internet, including UTD websites, it will confuse UTD's policies with other colleges or other random sources and will just make stuff up. To narrow the focus and bring context to our model, we needed to expand our tech stack. First, we used Haystack to crawl the UTD websites. Then we took the website text and put it into our database Pinecone. When a question gets inputted into our model, it is fed into LangChain, which talks to our Pinecone database and retrieves relevant information for our question. LangChain then passes our question and relevant info into ChatGPT. ChatGPT now has context and is more focused on the question at hand, so it provides a better answer.
And so for our modeling overview, how is it able to be fine-tuned in order to enable further optimization for questions and answering between students? So one thing we did utilize was prompt engineering. And so what is prompt engineering anyway? It takes many forms. And so for our use case specifically, I'd like everyone to think of sitting down with your manager at the start of your shift every day and being told exactly who it is that you are and what it is that you do. That's kind of what prompt engineering is in a sense. We are giving it directives on how to reply to people. We are making sure and telling it that it is factual with its response and that it is honest whenever it does not know the answer to your question. And with that, we're able to further optimize the output of ChatGPT. And one other thing that we did use is web scraping. So with web scraping, there are many websites that UTD has that are very useful and rich with information, specifically the FAQ websites. So if you go onto the admissions page, the academic scholarships, they all have an FAQ page that we specifically web scrape to get question answer pairs that we can feed so that our model knows exactly how to respond. And so we see here that once it web scrapes all the FAQ information, they turn into vectors. So essentially we turn text into a list of numbers and we store them into Pinecone, which is a vector database. And this database is special because it clusters similar things together. So you can see here, there is a banana clustered with this apple. And so if a user were to ask a question about scholarships, the database would pull question and answer pairs related to scholarship information from the database and feed it into ChatGPT.
So one of the obstacles we ran into was all the various Python libraries that we use. And some of our team is pretty new to AI, ML, and Python. So we have to really dig deep into some of the libraries like Pinecone, LangChain, and Haystack. And so, yeah.
We also faced problems when crawling UTD websites. So first, not all UTD web pages had good information. Second, even on a good web page, not all the scraped text was good. And finally, the web scraper had some difficulties reading tables.
Okay, so another one of the obstacles we ran into was hallucinations. And essentially, the person would ask the bot a question, and sometimes the answers would be like irrelevant or just sometimes completely wrong. And so to get over this, we use prompt engineering and FAQ dataset and web scraping.
So in order to make a working demo, we use something called Gradio, which links all of these components together to have a working chatbot. So I took the Gradio demo and put that into a website, into an iframe. So now we have a working website that has the chatbot in it that we can use. So we're just gonna ask it a regular question. At UTD, we have this program called Fast Track. So we're just gonna ask it like, what is Fast Track, and see what it says.
And there it is, everyone, our response.
So we're just gonna ask the audience, like, if you guys have any questions that you wanna ask our UTD chatbot. Just raise your hand.
There.
Okay. So as you can see, it gives us a estimated answer, typically May or June. Are there any other questions? So the question was, how many major specific credits are needed to graduate? So it gives us 82 semester credit hours. There's a lot of questions. Can you repeat that?
What classes is in your algebra prerequisite for?
Okay. So it basically scrapes this from, I think, the course catalog and gives us the prerequisite, like what is prerequisite for.
And see here, I believe it's actually, this is an example of hallucinations. So what is happening here is that text is getting split up incorrectly, but that's fine. We can see that there is a proof of concept here earlier with our recent questions. So is there any other questions?
So the question was, what classes does Simeon and Tapos teach, which is one of our professors here at UTD. So this is probably, it just doesn't have this information, so it's just giving us an answer. Yeah, so we're gonna close out the demo for now. So these are the plans we have for the future of our project. Right now, as you can see, it doesn't have that much information about the professors, as you just saw. So we're gonna try to implement, add the Rate My Professor API so that it can check like what students have rated certain professors and give you feedback. Like if you ask it, like if I should take this professor or take a different professor, it can give you accurate feedback. And then right now we're using the ChatGPT model, the OpenAI model, which is not open source and it's not free either. So we're gonna try to replace that with something called DALL-E. That's our plan for the future. And then obviously we want to minimize hallucinations so that we can get the most accurate information possible. Like for example, this one here, it says, we asked, what is UTD parking like? And it gave us the completely wrong answer of UTD parking is generally considered to be convenient and plentiful, which is not true at all. We never find parking here.
All right, and I'd like to thank y'all for taking the time out of your day to come and see our presentations. And if y'all have any questions, we'll be free to take them right now.
Does it recognize any other languages? Does it if someone wanted to communicate with it in a different language?
Right now, it's only trained on English text right now. That is a good point. Yeah, we do want to be open to a variety of languages because I'm familiar that English may not be the first language for everyone, so we do want our chatbot to be open to diversity.
Great concept. That's my only question.
Yeah, I think this project is really exciting. Honestly, I look at the demo. Although like make some mistakes that we know, like there's no perfect AI right now. So, but one thing I want to one concern I realize probably, if we give one AI system, give an AI tool, and other people will use. One underlying assumption will be the AI system will be reliable, and especially after we first do some tests to get very good results. We even check, the results are actually very correct. After many practice, let's say there are other students, they use the system multiple times, they'll say, oh, we can trust this system now because we get so many accurate results. It's impressive. But we do know it may fail to get some wrong answer. So probably a safer AI will be, can we let the system know what they do know? Okay, let's say like the question about the professor teaching adding course, that one. The system is so confident. Say, professor right now is not teaching any courses. Okay, so can we let our model we don't add the confidence make the prediction probably very low, right? And can we let the system and the AI models tell other people when we are not confident about the answer, we actually tell them, oh, we are not confident about this. Okay, so rather than just to very confidently give one wrong answer, probably it would be better that a model be more reliable than give one correct answer, which may not be able to directly respond to the question, but it's a safer answer. Yeah, that's my comment. But I think it's not just for your project; it's for ChatGPT actually. So, but that's one concern. In my mind, you probably can consider if any other engineering way can help to reduce this kind of issue. Thanks.
Thank you. That's a very valid point. Yeah.
All right. Well, thank you all for coming, and we'll get the next presentation underway.
Yeah, honestly, I think for this kind of project, it's kind of close to any certain software engineering research project can publish sometimes. So it's really nice.
And real quick, before we get started back on the presentation, I want to introduce our third judge here.
Babar Bani, been coming to UT for a while. I volunteer. I'll make a pitch for Dallas AI. It's a community of about 5,000 professionals, and we do free events almost every month. So look us up on, and it's free to join. You'll learn something. Thank you.
And just for the presentations moving forward, if you guys want, I would recommend just having a mentor over here who's pressing the laptop, and then have all the mentees stand over here on that side. And we'll have the mentees stand over here on this side and present over here and use that monitor.
Oh.
Yeah, go ahead and stand on this. Switch it right there. Yeah, cover that side. And then so you can just press it. And then everything stands over.
Microphone check. Got it. It works.
Okay. It works. You just set the stand over there.
Hi everyone. Our project is.
Oh, hang on one sec. Have you connected to a StreamYard? It's on our Slack. Like your Slack,
Like the mentor stuff?
or whatever Slack there is. So right before everybody presents, make sure that you go to the StreamYard and join in as a guest. It should be on the Slack.
Join the stream. How do you get to Slack real quick? What? Go to Slack. Try this like. Okay. Don't let anyone see my password. That'd be fun. What do I do after that?
There should be a link on the general channel
All right.
that you can join. So this is just like as on the stream.
Okay.
And once we see you.
Okay.
Share your screen.
Okay.
So you're gonna need to go back to the StreamYard.
Oh, okay, okay.
And then there's a present.
I see, I see.
And then share your screen.
Okay.
And then I'll ask you to share a tab and you can share your slides. Yeah.
Can I just do the whole window?
Yeah, whichever you want.
Okay. Let me check. Is this just streaming?
Yeah, so I'm just gonna.
Can you see this?
Yeah, I'm gonna just show.
Okay.
That's just.
And then unmute, right?
Mhm.
Okay. Cool.
And then make sure y'all also have this.
Hey everyone, this is our project Visual AI, which is an automatic crime detection system. I'm Meetup Chief, I'm Ashish, I'm a sophomore and CS major.
Hello everyone, my name is Deng Lin. I am a senior in computer science major.
I am Josiah Scott. I am a computer science major and I'm also a freshman.
I'm Gary Sanford. I'm a freshman and also a computer science major.
I'm Rishi Trivedi. I'm majoring in computer science and I'm a junior.
So today we're going to go over these contents. Number one, the problem being massive crimes and violence. Our goal, which is to create a CCTV footage, technical criminal offense, the data model and deployment that we have used for our project and the obstacles in the future of it. Number one, our problem. As you know, the current world problem, anyway, being violent crimes, gun violence in particular. And as you all know, how recently there's been an increase in mass school shootings, especially in middle school, and which has taken away a lot of innocent lives. And one proposed solution is implementing technology, which does real-time crime detection, which can prevent such incidents from happening. As you can see, these stats of the increase in mass school shooting over the previous decades has been increasing, and the violent crimes for every 1,000 American ages growing older. So our goal here is going to be making an application that examines CCTV footage to detect criminal threats. There are 3 steps we're going to do for that. First one being detecting any suspicious activity. Second, verifying if it's violent or not. And third, returning it back to the system to take the necessary actions.
So for our data, for our video classification model, we use Kaggle, the real-time violence data set, and it's comprised of 1,000 violent videos and 1,000 non-violent videos, which makes up about 1.2 GB videos. And for our anomaly detection data, we use UCF crime data set, which has thousands of videos which are pre-classified into burglary, fighting, and shooting, which makes up about like 6 GB videos, which is a lot in terms of videos.
Alright, so on to our models. We have trained 2 models for this project. The first one is anomaly detection, which we trained with the UCF Sky data set. This categorizes each of the videos into 1 to 14 minutes, indicating what time is used. And then there was another one, data classification, which simply had one goal, can differentiate a side from an online factor, so it's changed using the UF file at the same time.
A little bit more detail about our video classification model. We train our model with 2,000 video, including 1,000 for non-violence and 1,000 for violence. We use a pre-trained model called video and MAD, which we will explain shortly. The reason we use a pre-trained model is to test some basic understanding about classification, video classification. So we just took advantage of that fact, combining with our 2,000 training videos, and so that we are able to improve and also enhance the performance of our model. I want to mention during our developing process, we use 2 important libraries. The first one is the PyTorch video. This one we use to prepare the input video. The second one is the transformer, which we use to measure and also train to measure our model. The last thing that I want to talk about is Hugging Face. After we finish in our training process, we publish our model into Hugging Face. So at the end of the day, if we want to use it again, we just come and grab it and use it as we want, so we don't have to run our code and train our model all over again.
As you can see, our accuracy is pretty high at 95.33%. This is largely in part to using a pre-trained model trained on 65,000 videos. On papers with code, the highest was 97% with a real-life violence data set. Ours is 95%, and the one below that was 94%. So our model performed relatively well across the data set. So in case you were wondering how the video works, it takes a video, puts it in the clips, and then it takes batches of the clips, and then it processes into an encoder, and then it tries to predict what's going on between those batches. And then we get labels from that by basically predicting whether it's video, like a violence or non-violence based on what it predicts.
So that was the other video classification data set. Unfortunately, our anomaly detection data set is still a work in progress, primarily because we ended up treating it with more normal videos than of the other 13 different classes. And what you have is, if you would have a multiple choice exam with 14 possibilities, and you don't have to be answers are going to be A, you put A for everything. That's what our model did. So we're going to have to get an equally increased amount of videos, and we're going to have to be working on that in the future.
So obstacles and future.
Okay, so now we're going to talk about our deployment process. So it starts off on our web browser, which our backend uses Flask. So whenever you upload a video, it takes the video, puts it into chunks, and then it takes those chunks and turns them into tensors, and then it connects to the REST API, and actually it sends the tensors to an S3 bucket, which sends the location to a REST API, and then the REST API uses the location and sends a Lambda function that sends the location in the S3 bucket to our model on an AWS inference. And then from there, it gets low iterations for violence or non-violence, and it sends them all the way back to our backend. And from there, we can determine which clip, which part of the video is violent or non-violent, and if the video is violent as a whole.
Again, for obstacles and future, we came across 3 major obstacles, which was complexity of the project. So we had to learn new concepts and work with an uncommon library. It was fairly new for everybody, and relatively newer concepts were discovered throughout the project. Also, for time, we all had conflicting schedules that we get out and work on the project and develop a successful project for that. So we worked on that, and we had to come up with a plan every single time, and which shortened us time, led us to an unfinished model, like Josiah said. We fed up with a lot of non-violent video data, and that's but we don't have a finished product for an anomaly detection model. But our classification model works perfectly fine.
So ideally in the future, we'd be able to finish our second model. That way, we're able to get more than 2 labels for the video. That way, when we use alert someone, you're able to say if it's like an explosion, like burglary, or assault has happened. Additionally, we would like to improve the accuracy of our first model. Although it scored 95% across the real-life violence data set, it's very specific on what it counts as violent and non-violent. So if we could make that have a wider range, that would be great. Additionally, we would like to be able to make our computation faster, and this could happen by hosting a lot of the stuff on Lambda, because currently it breaks down the videos and turns them into tensors all locally. And if we're able to do that on a Lambda function, it would probably increase the speed of our model. Lastly, getting real-time feedback would be more applicable for CCTV cameras. So that would be a nice thing to do in the future. All right, so now we're going to go on to the moment you're all waiting for. So our product, Visual AI, the eyes move. We have eyes because it's like watching the crime to happen, all right? And so then you press get started, and it's purple, so you're like seeing into the eyes of the criminal, right? So then you upload your video. So we upload this. All right, we press upload. And so then what it's doing right now is taking that video, putting it into chunks, and then it's going to be sending it off to AWS and S3 bucket. But this takes some time. Usually takes around like 45 seconds. So we prepared like the results for us already. So this is what the result would look like. So it had it's like a 12-second video, and then it said that the video as a whole is a thread, and it outputs the frame that has the violence. So as you can see, this is a pretty violent frame. And so this was the most violent frame. It also says like the location of the least violent frame as well. So let's just see. So this is almost done. It does take some time, but it produces the same thing right here. So do y'all have any questions?
What background is?
Not today. Yes.
You guys mentioned that the videos you guys trained model on.
So UCF is for our second model that we were training. We were almost finished with it, but we got into some issues along the way. And if we have one more week, we'll soon finish it.
Anyways, my question is, are those videos involving threats with humans? You know, like they identify a bot as a threat.
Right now, it currently identifies any sort of violence that is occurring as such as like large scales of movement as a threat. So if you're like being harmed enough, then it would be able to detect the threat.
Yeah, I have some questions and suggestions. So first, when we look at the demo roaming, so right now I think it's still very slow, right, for roaming. When people reason if you are using a very large trained video model, like video ME model, usually like model training, you have larger size, you have big data, and you can get better performance. And but the downside, usually the model size is large, and the inference time is long. So one way is first you can compress the model. So you can reduce the model size using certain compression technique. And second, you can try other more efficient model, for example, IONNet or other relevant efficient model. That's certain way you can speed up your testing. Second, that's one question about the data. So a lot of violence, inactive events probably captured tonight. So for a model probably, you will say anytime video. So after training, but during testing, there are many different scenarios. For example, blue light, nighttime capture data, visual noise, very noise images can be captured. And within day, like today, yeah. So there's a rain, there's a snow, certain stuff. All the different visual conditions may decrease the performance of your model. So you probably can consider to further increase the generalization probability in the future. And another point, considering combining audio, that's probably one way. So let's say there's sound of a gong. Combining the additional modality may like making input the reverse nearby model and increase the performance probably. Yeah, that's my word. Yeah, thank you very much. Anyway, very nice. Yeah.
Thank you. Thank you.
It was very interesting. And I'm impressed by your capabilities. I'm curious about eventually expanding this model. So if I think from potential customer point of view, I may want a model that searches for violent incidents, but also say for shoplifting or harbor. Now, going back to the way you trained the model, I'm curious about the delta between the pre-trained model that you said you started with and what it took to train or to fine-tune your model to this specific application for detecting violence.
So we haven't deeply changed video mainly just as a better understanding of the model in general, I believe. I think it has already has these classifications. The classifications are, I don't think video MAE already classifies them into certain sets of kinds. So we basically all of the labels and the entire training was basically we did that. That's the primary difference.
Oh, so we have which is trained on like the UCF 101 data set. So it does have like labels already attached to it, but they're not necessarily like crime oriented labels. Like it could be like a baby crawling or like basketball or stuff like that.
What did you take in terms of application? If you wanted to detect, for example, breaking, and I like the suggestion of getting audio input, what would it take? How many incidents would you need and what computing power would require to detect breaking live?
We could just, if we finished the other model, it would have been able to detect like break-in or like a robbery or an assault.
I don't really know how much.
Does that answer your question?
Thank you.
Okay. Any other questions?
I have one question. So you mentioned the accuracy of the classification model is 95%.
Yes.
Did you get a chance to look at the 5% errors and did you see any patterns in there?
We did not really have a chance to look at the 5% errors. It was probably just very violent actions that like are really hard to detect by eye or like where people aren't moving as much because the model mostly detects a lot of movement as a violence.
I really like the work you guys are doing. There's a lot of potential. And I think that it needs more work.
Yeah.
Because I think I remember seeing on Twitter a video of a cat took down a very Christmas tree and was caught on the camera. But seriously speaking, I think one of the things you want to do is always look at the false positives and see if there's any bias in the video. And obviously, it requires a lot more work than what you can do, but just something to keep in mind.
Thank you.
Yeah, I probably better one sentence like all your words. I think that's very important to know why it failed. The reason that for us we do research, you just do a small data set. You just fail like 5%. But when you try the model in real world system and your customer will use, let's say customer will always fail for the standard. It's unacceptable for customers. So I guess that's very important.
Any other questions? All right, that's everything. Thank you.
Good job, guys.
Thank you.
All right.
James Robinson.
So.
So we finally have all of our judges here, so can we get a round of applause for all of the judges? Thank you guys so much for being here. Really awesome. So Dr. Levine, real quick, is just going to talk, introduce himself and courses.
Thank you. Good evening. Dr. Sheen Levine from School of Management in Columbia University, New York. And I'm here to judge. And also here to invite you to join. I'm
not going to talk about the mechanics of artificial intelligence. I believe that's been my
Okay, just make sure when I turn it on that it's not.
That's just a program audio, right? The speech audio is still on for the room.
Yeah.
So we don't need the program
Oh,
audio.
you have anything to do
Course is dedicated to understanding how artificial intelligence
Let me know if you shared.
organizations, management, markets, and society in general. Small experimental class that I designed with Deeper James, that was head of AI Meta. He helped me design the course, and we are launching it in other than beta, an alpha version, limited to small intimate group of students that will work with me, with him, and other industry leaders to understand how artificial intelligence changes business and changes society. If you're interested, drop me an email. It's Levine@UT Dallas, or register for a class. Thank you. I'll be around and get questions.
Okay, make sure that everybody stands like this way. We wanted
We're
to
like
do-
splitting.
we wanted
3
to
here,
do-
2 here.
Okay, so that people are gonna be on. Is that okay? Okay, do you guys want to be on video?
Sure.
Yes, then good, all on that side then. Well,
I mean,
just,
if you want to be my dad, will send you a video.
okay. Wait, you can, they can. What's out here?
Yeah, well, it's fine. Yeah. Who wants the mic?
Oh.
Okay.
We don't care about putting on the video, because this one, the video, we need to be present over there in that corner, right? It's fine, right? I don't care. Wait, wait. No, stay the way you are. If you guys need to pass the mic to that side, give me the mic. We'll hand it. We'll hand the mic to you.
Aiden has invited my parents here. Please don't look at them. You'll get confused. Don't worry about it.
Okay, stand properly. Why are you guys standing like that?
He's gonna go in front.
Yeah.
All right.
Okay.
Imagine this. Dr. Schrader is the on-call ER doctor. Then a patient, 65 years old, named Walter, enters. He looks distressed. He complains of chest pains and difficulty breathing. Dr. Schrader correctly admits him and calls for an X-ray. However, this X-ray is hard to interpret. Despite consulting with other doctors at the ER, he's unable to come up with a diagnosis. Suddenly, he remembers Hugo, the healthcare utility AI for guided outcomes. Dr. Schrader uploads the X-ray onto Hugo using its easy-to-use interface integrated smartly onto the hospital's information system. Hugo quickly
determines that Walter is suffering from pulmonary dysfunction and cardiomegaly. Using this information, Dr. Schrader is able to conclude that Walter has acute cardiorespiratory failure. With this diagnosis, he is able to start treatment quickly. Without Hugo, the delayed onset of the disease, as well as the delayed diagnosis, could have led to worsening conditions. However, thanks to Hugo, the doctor is able to make a quick diagnosis, even when the x-ray was hard to interpret. Now, allow me to introduce the team behind Hugo.
Hi, I'm Sonia.
Hi, I'm Forrest.
Hi, I'm Mario.
My name is Atin.
My name is Varun. And these are my mentors, Purna and Adisha. Every year, 7.6 million visits are made to the ER for chest pain alone. And it's speculated that there is going to be a shortage of 35,000 radiologists by the year 2024. And on average, it takes about 90 days for a normal diagnosis for anything chest condition related.
Up to 30% of abnormalities found in chest x-rays are missed every year due to small amounts and different varieties of masses that can be seen in chest x-ray, which can be led to malpractice use against radiologists, which are as high as 44%. In order to bring those numbers down, our mission is to help ease the burden and stress on radiologists and medical personnel in urgent cares, hospitals, and any doctor's place all over the world. Physicians are an important component of our nation's medical infrastructure, and as you've seen in the last few years due to the COVID-19 pandemic, there has been a massive strain on our medical personnel. Our mission is to create a web app using 4 models, which a user will then put in. So there's a web app. A patient will put in a medical chest x-ray into the app, and using 4 models, it will tell you the patient's age, gender, and medical condition.
So what is the process behind Hugo AI? So we started by researching what CNN models we're going to be using, how we're going to work with the Kaggle data set, and how we're going to use that with the Novobases. Once we figured out what the overall blueprint of what we're going to do is, we moved on and we started training our models. We had a lot of trial and error, but in the end, we were able to deploy it successfully on a web app.
All right, so our data from Kaggle actually came from the National Institutes of Health, which has over 45 gigabytes of data, which is 112,000 images. And we took a subset of over 30,000 images due to our constraints. And what we did was we actually passed them through a convolutional neural network. Essentially, in simple words, it's a machine learning model which has multiple hidden layers inside the input and output blocks, on which the X-ray images are passed through. Specifically for our data set, we prefer to going fine-tuning a pre-trained model called ResNet 152. Now, in our research, we compared VGC16 and ResNet 152, all with ResNet 50 as well. And we can realize that ResNet 152, due to its 152 hidden layers, was much more accurate. It did take a few extra seconds to find out the output, but it was much more accurate compared to the other ones. All right, so Hugo is built over 4 major ML models, starting with our flagship pathological conditions classifier. Essentially, what it does is that Hugo can identify 14 unique chest abnormalities aside from a no finding label. Then we have a gender classifier which can identify if the patient on the X-ray is male or female. Then we have an age classifier which can tell if the patient is an adult or a child. These are really important in emergency situations. Last but not least, we have a view classifier, which can identify if the X-ray is anterior to posterior or posterior to anterior. It's only front to back or back to front. All these 4 come in and make Hugo an amazing emergency services model. And our average accuracy over all these 4 models is over 93%, which is great for the healthcare industry.
Some of the technologies that we implemented for this project were FastAI, which was a learner class that basically integrated every single necessary info for our model and helped train and develop it. Another one would be PyTorch, which is a machine learning framework based on the Torch library. And for our website hosting, we use DigitalOcean, which is a cloud-based hosting service.
It all comes down to this, our demo, HugoAI.cc. As you can see here, we wanted to keep it simple for the user experience, and all we have here is a upload and an X-ray button. And that's it. Within a few seconds, we get the pathological condition along with the description, because let me be honest, I don't know what effusion is, and I want to know what effusion is. We got the gender, the age, the viewing position, and normally people would want to upload more than one X-ray, so I'm going to open it up to all of y'all. I have 5 images on here, 1 to 5, just blurt out a number, I'll put it in.
4.
All right.
Let's do it.
Wait a couple seconds. There you go, infiltration. Does anyone here know what infiltration is? Exactly, that's where this comes into play. I'll do one more. Anything other than 4, 1 to 5. 2. Infiltration again, okay. Moving on to our
I know you're thinking, wow, what a great app. What more could we possibly do? Well, our next steps will be to incorporate X-rays other than just your chest, such as your arm or legs. So I know if you guys have brothers and sisters, your brother and sister breaks a leg, it can be a pain going at 12 a.m. to the emergency room to figure out what sort of fracture you have. So we would like to incorporate other X-rays as well as MRIs and CT scans to help ease the burden on our medical personnel.
Additionally, we'd like to improve the web app's accessibility. One way is to make this readily available to more ERs, urgent care centers, and hospitals across the US. Additionally, we hope to integrate it with patient portals, leading to a more informed patient base. Thank you everyone for your time. Here you can experience Hugo for yourself using the QR code above, and please keep Walter in your prayers.
Meh.
We'll open the floor for questions. Yeah, so the data set was actually over 112,000 images total. It's about 45 gigabytes. But we actually toned it down to about 30,000 images. This includes images from all conditions, all 14, 15 conditions, all of both genders, both views, and that was about over 11 gigabytes. But we actually experimented with multiple different. We went for 5 gigabytes, 10 gigabytes, 15,000 images. We settled for 30,000 because that was a sample size which reflected the overall data set in a much better way, while still keeping our resources used in a good manner. I hope that answered your question.
Do you have any doctors in the family?
Do any of you guys have doctors in your family? No.
Yeah.
What is the accuracy of the models? I'm asking this because of the possibility of doing accidental podcast answers and maybe being sued for medical malpractice.
So 3 out of our 4 models came out as around 98 to 99%, almost always accurate. The only thing that we had a problem with was the pathological condition one, because we had some images had like 4 different pathological conditions, whereas other images only had like 1 or no conditions at all. So, and given our data set size and training resources, we were able to get around the 92, which was a sweet spot. Okay.
Additionally, I want to add that obviously in the field of medicine, we can't let AI determine everything. This tool should be used to help medical professionals in diagnosis.
After all, like in our name, right, we have Hugo, so GO is guiding outcomes. So as you said, right, there could be a mistake. So we don't want to replace radiologists, we don't want to replace specialists, we want to guide a final outcome. We don't want to dictate it. So, but that's the reason we came up with 92% as a sweet spot.
So probably I can add something like, medical is a very important area of the AI application, and it's a very critical area. So besides showing certain like accuracy and improvement for this area, I think it's very important to make the AI model more expandable. So we know, okay, give the input, we get output, but why? Like for example, you have the pictures, and you give the picture, you give certain decision using the visual content you provide. But why the model give this output? Can you let the model be able to localize the content which have to make such a decision? Because you give the picture, there's so many different visual content, and not all of them are responsible to make the final decision. So it will be very helpful in your model. We'll be able to make the model more interpretable. For example, give the prediction, then they'll be able to have certain attention or others to tell other people why our model makes such a decision, what kind of contextual information, visual information used in the picture. I think that will be very helpful in the future. Yeah.
Absolutely.
Yes, thank you for that
Thank you.
suggestion. Do we have any other questions?
Yes.
So what was the accuracy like determined on? Was it like a test set?
Yeah, so remember I talked about the 30,000 images, right? So when we, so Fast AI we use, which is what essentially brought all our functions together, there's a function called learner. And in the learner function, essentially you pass a PyTorch-based model for fine-tuning. And over there, you can add a threshold and a test and validation split ratio, we also had a random splitter, which randomly split it on a specific ratio, and then it automatically on its own can determine how much accuracy it has by testing on both the knowing of the testing set, but also the validation set. So does that answer your question? Yeah. Okay.
We good?
Yeah, nice one.
What's your
Thank you.
Thank you, guys.
Thank you.
Thank you.
Thank you.
Thank you.
Yeah. The word.
For our shit. Yes,
I don't mind.
there's gonna be like come right there.
I teach one.
Yes. You have an issue? Yes. Yeah. Oh, are you Hugo? No. Did you guys try your screen recording? Eamon should have sent it.
Thank you. I have to look out.
Yeah, you just jump in. You can still be able to use your laptop. Yeah, I can just open it.
Yes.
Yeah. Oh, okay, actually, I think you do have to click it. Keep the pace going. and it's like a mission. I think like story settings or whatever, like you turn up the
The driver issue. So we had
oh, it's a driver issue.
Yeah.
Okay, one thing we could do is like you share the slides with us.
The only thing is the presentation.
Yeah.
What do I share it to?
Oh, we can.
You don't have a phone or? Yeah, no.
Okay.
Yeah. So it's on Slack. It's on Gmail.
Wait, did I have some issues?
Yeah, you have to. Wait, you can read it honestly. Yeah, it's not working. Okay, just try to enter it online. Because it's. Maybe try unmute. Because it's like unmuted there, so I think it should be fine. Oh, yeah, you have to present. And then share screen. Yeah. Yeah, that should be good.
Oh, there we go.
Hello.
Hello. Hi. Hi, everyone. Hi, judges. Today we're going to talk about our semester-long project that's called Recipe. Our motto is effortlessly plan your meals with just a snap of a photo. Before we get started on the project and what it is about and why we're doing it, we're going to meet the team.
Hey guys, I'm Armand.
I'm Amir.
I'm Danny.
Danny's our mentor. Yeah. Okay, so before we go into how it works, we're going to talk about the problem. Raise your hand if you know how to cook. That's okay. So if you don't know how to cook, you have an issue where sometimes you buy stuff, you have a kitchen, you don't know what you're gonna make, you have some ingredients, maybe you cook something and you have some leftovers. The problem is that it takes a lot of time and effort into just cooking a meal, planning a meal, knowing how to cook it. So the solution we have for this is that we're going to automate the process of ingredient identification and recipe suggestion. Now, Ramon is going to talk about the use case of this one.
With our project solution comes with various use cases. If you can imagine being a college student for the first time at a dorm with new experiences, you can understand that it's pretty difficult to learn everything at once. One major component, of course, is cooking. A lot of us go into college, including myself, barely knowing anything, only being able to make a PB&J sandwich and grilled cheese at most. So with our project, there's a lot of use cases. One main thing is within our app itself, we are able to present a lot of recipes to provide new ideas so that somebody who's a novice at cooking can become to a higher level, up to the level of a chef itself. In addition, with our project, one main concern is a lot of us have a ton of different items in our fridge and even in our pantry, but how much of that do we actually use? A lot of that in reality turns to food waste. So with our app, you can scan all your ingredients and figure out recipes with things maybe you don't use very frequently whatsoever. In addition, there's personalized recommendations that come with our app, such as if you have dietary restrictions, you can figure out meals that go according to what your needs are. And finally, there's also meal planning, which is a big component, especially for someone like me as a college student, where I don't always have the time to make a meal every single day for lunch, for dinner, and breakfast, where I could rather just make some solid meal for the whole week. As for our project, in our tech stack, all we used for it was Python and their libraries. In specific, we use Tkinter, which is for our interface and user experience. And for our models and all of our AI and machine learning, we use TensorFlow, Transformers for our data set, and then we also use NLTK and TF-Learn. And here we'll show our demo. So with our demo, what's going to go on is our app essentially is you take a photograph of all the food items that you have in your kitchen, whatever it may be, and what will happen is the app will produce results of possible recipes you can make with whatever you have, like I said previously. And the way the whole model works essentially is first we have the phone app that takes the picture, and this will be sent to our first model, which is a CNN. CNN is a classification model for figuring out a classification for an image, meaning that for us, it would be taking a photo of these food items we have, such as the egg, the bread, the milk, and being able to have our model say, well, yeah, that's milk, that's bread. After that, once we have these ingredients themselves, we use another model for our recipes, which collects it based on whatever terms we have. And finally, we have our recipe list, which has an image of our the final output recipe, along with a link to how to actually create the recipe itself. So as you can see, Anand first took a photograph of the food we had. And on the right side, you can see it scanning and determining what items are visible in there. So as you can see, it shows milk, eggs, and bread, which is exactly what was in the image. And following that, you can see the list of the recipes as a whole. So there's all these different types that somebody can make just with what we had. So for the first part, like I said, was the CNN model. So what we used was MobileNet architecture. We specifically chose this model for computer vision because it's very lightweight and it uses technology that makes it so it's portable. Of course, it's on MobileNet, so it's good for using it in mobile applications. So what it uses in specific is depth-wise convolution and point-wise convolution, which is very valuable. When we were actually using this model, we had to train it with a custom data set. So what we did is we manually picked out images for certain food items that we thought were essential. So things like we often use bread and eggs in meals. After that, we used augmentation, which is a technique where we can create multiple, we can create higher quantity of data by using different techniques such as like scaling and rotating the image itself. After that, we have to pre-process our image into the model, meaning that we just have to transform it into what the model's specific input needs. And as a result, we would get the output. And finally, we did some fine tuning. So what I mean by that was training the model in an efficient manner so that we'd have a good learning rate, which would improve each epoch of the model.
So the second model, the one that I work on, is the part that recommends the recipes. It uses deep learning. The goal for this one was to just recommend recipes based on the detected ingredients. The method I use for that is a TensorFlow package called TF-Learn that uses a neural network. The data set we use for this is a little bit restricted because we have a few ingredients and we're still doing a demo. So it's a JSON file containing intents, patterns, and responses. And next one, I'm going to talk about the workflow. So we have pre-processing, which involves tokenization, stemming, and just finding a bag of ingredients that we're using for the recipes. Next, we use a neural network. The neural network architecture is that there's an input layer, there's two hidden layers, and there's an output layer. The two hidden layers and the input layer are involved in mapping the ingredients to the recipe. And then we have a prediction, which is to process the user input, predict the intent, and map to recipes. For the output, we have recipe suggestions with ingredients, condiments, and a link.
Now, we gotta talk about the competition. Our first competition is Supercook. You might have seen this on TikTok, for example, and this is a website and an app that essentially takes in all the ingredients that you have in your pantry and essentially generates recipes with that. We have an upcoming app, or MIT students have made an app called Pick2Recipe, which takes a completed food and essentially gives you the recipe to save for later. And then of course we have ChatGPT and general search engines, which are able to provide recipes. Now, what makes this different? The main difference is that we want to ease the access. Unlike Supercook, we want to use a photo and get all the ingredients. Whereas instead of just inputting all of it, instead of inputting all the ingredients, which seems a little tedious. And essentially converts our ingredients into food. Our struggles include connecting the front end to the back end. This included understanding or wrapping our heads around the project, which figuring out how other projects work and trying to build it based on that. Some libraries were hard to work with because they were really old and different versions of our pipeline and troubleshooting in general. But object detection and little things with cameras and finding the ingredients were also a few issues that we ran into.
Some future AI additions were including an object detection model instead of the CNN we use. The purpose of this would be so you could see real time on the app where the ingredients were selected. This would just be a more quality of life update to it.
For the NLP model, we could have gotten more than just the ingredients. We can ask what type of food the user wants. Do you want breakfast, dinner, lunch foods? Do you want sweet or sour? Do you feel very hungry or do you want a diet? And we could use that to maybe make a chatbot that could recommend recipes that are more tailored to what the user wants.
And then for our database storage, we want to be able to have a wider range of food that the AI is able to analyze and also output, which goes on to the wider data set range. For the future development additions, we wanted to make a completed app with a mobile front end based on Flutter and probably Firebase for ease of access. We also want to add query constraints, which essentially add additional info, such as if you have a microwave, an oven, essentially what tools you have on hand. We also want to be able to create user profiles and favorites so you can save the recipes for later. And then we also want to be able to take in multiple photos instead of putting all the ingredients you have into one photo. Any questions?
So what's your training data set for the first part?
Yeah, so the training data set we used was just custom, so it was manually made. So we had it, so we literally just put in images of the food items themselves. So one thing to also consider was, of course, when you have certain foods, like for example, bread can be, you could scan it in multiple ways. So you could do like a slice of bread itself, but you could also have the whole loaf of bread. And same with other things, like for milk, you could have the whole milk bar, the milk gallon, or you could have like a cup of milk. So these were things to consider when you're making the model so that it would be able to differentiate better between the different food classifications.
Yes, it's very interesting project, and I'm considering you can further even like extend the project to one AR application. And you will be able to further impact in the process. Right now, you give the static picture, and you run using your system and get the output. But it would be interesting, like certain product the user can further integrate the system. That would work too. Yeah, that's my suggestion. Yeah. Anyway, very interesting project.
Thank you.
Yeah, to follow up on this question, first, your presentation is very well done, very well presented. I think that our business school students should come and learn how to create. As far to the content, an impressive application. So I have two follow-up questions. One, continuing with your idea, what would it take for a user to train new ingredients? Do you envision that a user would be able to add ingredients?
I think that would be a good future addition. So right now with our app, it only has 6 classifications. We chose 6 just to make it so it would be easy to train, and we chose them specifically because these are items that would be frequently used. But of course, everybody has in their own cultures their specific things that you might use. So it would be definitely valuable to have more items within our data set, so then there could be multiple classifications. But I like the idea where you could be able to, maybe there's something in specific that you have that maybe is not found commonly around the world, where you could input. That would be a good application, I would say.
Mm-hmm. And the second question is, and this probably reflects my ignorance, what's the benefit of using an NLP model to find recipes? Why wouldn't you simply use an algorithm that searches for all occurrences of the word bread in a database of recipes?
I think using an NLP model or a chatbot just adds to the user experience. For example, if the chatbot could ask the user what type of food they want, or what time of day it is, if they have any dietary restrictions, just to make the user feel like they don't really have to put in that much thought into the recipe, instead of you just putting in just your ingredients and saying, I want recipes for this. You can say, I want this, and I want this time of day, I'm feeling this way, I'm on this diet, and I want a better recipe recommendation that's more catered to what I'm looking for.
And these are future extensions.
Yeah, these are future extensions.
Thank you, well done.
Thank you.
I think so, yeah. It's Ryan, right? Yeah. I'm not completely sure it's not working. Let's find out. Let's check it out. Does it? Is it? I hope it is. I hope it is. I don't know. There we go. I guess it does work. Oh, there we go. I guess it does work. Yeah. Drew, you got it? Oh, there it is. Oh, actually. Go back to the share. Yeah, and then click on present. Slides, or share slides, or share screen. Yeah. Put on your share screen. I don't know why it's getting your no, you want the entire screen? Yeah, that works. I click on it. I don't know why it's getting your camera. I mean, it's video. There we go. Cool.
Yeah.
How are you presenting it? How do you present on this? Slideshow. Slideshow. Oh, sorry. You got it.
Hey everyone, our name is Quant Realm and we'll be presenting.
It's not on.
Oh. Hey everyone, our group name is Quant Realm and we'll be presenting our portfolio analysis project. My name is Anthony.
My name is Jevin.
My name is Steve Vishnu.
My name is Bennett.
So as you guys all know, the stock market is often advertised as a place where users can invest and trade their money. Looking at past statistics, index funds such as the S&P 500 have had an annual return of 10%. This may seem like a good deal, but the average isn't a good indicator for the majority of new investors. For most beginners, research have found that 3 out of 4 people quit after a year due to their lack of profit. We've narrowed down this problem to 3 factors. First, when researching a new field, there is often an excess amount of information, making it harder to separate the right ones from the misleading ones. Secondly, stock trading can be heavily volatile, which makes it hard to analyze patterns within the market. This is coupled with the fact that most beginners don't have the capital to experiment with different methods, and investing turns from a way of securing your future to just online gambling. While there are tools out there such as Bloomberg Finance or techniques such as swing trading, these methods usually aren't beginner friendly. Our solution is to create an app that acts as a guideline for new investors. We've implemented tools such as trend predicting graphs, portfolio optimizers, and different indicators such as candlesticks and RSIs that you can use to study, which is all accessible through a simple UI that is capable of returning real-time predictions within a couple of seconds. So in making this app, our mission is to help people of all ages to have a better grasp on their future. However, a small disclaimer is that you should do your own research before investing, because we won't be responsible for your losses.
We won't. Moving on to the implementation details, we created an easy flowchart for you to get a good picture of how we went about creating this process. It started out with the data collection and pre-processing, and then it goes on to us choosing models, training it and evaluating, and then finally deploying it. So for the data collection, we implemented the Yahoo Finance API, and we got historical data up to 2 years where features of the data were the open, the high, the low, the close, and then the volume. For the pre-processing, however, we had to normalize quite a bit of the data and input some missing values with linear interpolation. Just because stocks are so volatile, we can never truly predict how it's going to act. So we did normalize the data with the min-max scaler. And for this is going a little bit to the next slide, but for our model, we had to prepare a time series data for the LSTM model, just because that's how it would more efficiently read the data. And for our model selection, we chose LSTM just because it seamlessly handles time series data, and it's just more accurate when it comes to this, and it's more accurate than the traditional RNNs. And we just found that to be the best one. So we use stacked LSTM model for training the data. It stacks upon how exactly the days of the different open and high, the lows and closes are. And that's how the model trains it and retrieves the data. And for training it, we decided to do a 70-30 training split. And we had an epochs of 100 per stock in the DJI index fund, as well as an Atom Optimizer for gradient optimizing techniques. And for the amount of layers that we have 4 layers, 2 dense layers, another layer, and 1 for the gradient optimizer. And we also used early stopping to prevent overfitting as well, just to keep the model more accurate.
For the model evaluation, we use 2 methods of error, the mean absolute error and the root mean squared error. We achieve levels of, on the Dow Jones Index, like over the 30 different stocks, we achieve the mean average error of 2.35 and an average root mean squared error of 2.87. For our top performing stocks, we actually received scores as good as on Cisco, the Cisco ticker, we received a score of 0.82 for the root mean squared error. And on the Verizon ticker, we received a root mean squared error of 0.61. For implementing our user interface, we chose to use Streamlit because it's a Python library that integrates seamlessly with our model, and it provides like a great interface for users to like interact with the platform.
Let's move on to a demo. Do you want to speak?
Oh yeah. So initially, the user is greeted with the dashboard showing them the specific ticker. And there are 3 indicators that the user can use to decide on whether they want to use the stock. The first one is the moving average. And the moving average has both like the moving average for 15 days and 60 days. And generally an indicator that a user might do is when the moving average lines cross, they may make an option to either buy or sell the stock. Secondly, we have candlesticks. And then the user can just use natural technical analysis to analyze these candlesticks to make their decisions. And lastly, we have the RSI line. And as a general rule of thumb, new users can expect to buy a stock when the RSI is at 30, and then sell the stock when the RSI is at 70. Secondly,
this is where it gets cool, guys. But once it loads, just give it a second.
Secondly, we have our model prediction. And here, the line shown in the light blue is the historical data, and the predicted data using the LSTM model is in the dark blue. And in comparison to the actual data that we received in the meantime, the model performs actually quite well with an RSI of around 2.3. Actually, not RSI, RS and like root mean squared error.
Yeah.
And lastly, for portfolio optimization, we implemented some standard techniques, standard industry techniques to evaluate both the risk and the volatility of the stock. And we'll show an example on the Apple, Cat, and Cisco tickers. And here we fetch data from an API, and it returns three like values: the percent expected returns, the percent annual volatility, and the Sharpe ratio. And a lower Sharpe ratio meaning that it is a more risky collection of stocks.
This percent annual expected return is for annually. So if you invest in these three stocks, it'll give you a weight. And say you want to invest from May 17, 2022 to May 17, 2022, for that year, you should expect a 15% return on these three stocks with the weights that it gives you. That's the portfolio optimization feature of this app. Should we move on?
In the future, we'll be enhancing the model performance through feature engineering and also expanding it so it will have more stock market and symbols. Mainly, we'll be utilizing portfolio optimization techniques for better investment decisions. Overall, our project uses LSTM based stock prices for stock prediction system. Also successfully deploying and integrating it with the web interface. Also, project demonstrates of AI finances and investments. Thank you. Thank you.
Yes, I have a couple of questions. First one is your project available to like anyone?
If we make it, available to anyone, yeah. Right now, if we give you the files for it, if you just download Streamlit and run Streamlit, you can use it, yeah.
And then if it's available to anyone, how does your project impact like demand or returns on certain assets?
Could you elaborate?
Start using it, when that affect the demand and consequently the return on certain assets?
Could you elaborate the question?
So your project aims to provide or aims to guide beginner traders to make more correct decisions, right?
Correct.
So if enough beginners start using this and they all start making the correct decisions, wouldn't that impact like long positions, short positions? Would that impact the return on assets?
I mean, of course it would, but I mean, like anyone can, like the market is free, anyone can make any decision they want. And I guess you could say that it would have an effect on the market, but I doubt that at the state right now that our project would have that much impact on the market.
Another impressive presentation, something that's much closer to home. Let me start by saying that you picked a difficult problem to tackle. So I did some work on Wall Street, and you and the audience may be surprised to hear what is the hit rate of professional traders in Wall Street. So people that all they do is trade stocks, not as a hobby, not as that's their day job. Their day job is to trade stocks. The incentives are humongous. The incentives are millions of dollars in bonus at the end of the year. What percentage of their trades do you think end up being profitable?
If I had to guess, less than 50%.
So slightly over 50%. If it were below 50%, you'd probably lose your job. But the point is that those that succeed in the job are not much better than flipping a coin. So if you can improve their hit ratio by 0.1%, you've done a lot. So an impressive model, an impressive problem to tackle using these instruments. And so I'm curious as to what goes to your prediction model. Obviously, stock prices are what we would call in statistics autocorrelated, right? So the price yesterday is a good predictor of the price today, and the price 2 days ago is slightly worse predictor of the price today, etc. So all you put in the model are time series of this stock. Do you predict it using historical performance of this stock, or does the model look at all of the stock prices in the model? And what do you imagine can be added to your data set?
Gotcha. So right now, so we have 30 models for every single stock inside DJI, and each of the models only look at the stock itself, the historical data, how it's been performing for the past 2 years. So it uses that in order to come up with the next 60 days prediction. But yeah.
It doesn't look at the other stocks.
It does not look at the other stuff. We haven't implemented that yet, just because we're in such the beginning phases. What I want to do potentially is we want to keep on working on this and honestly optimize it a lot more than this. Because right now what it does, it correctly predicts it, but I want it to go even more into the future. And I need more data. And we were considering doing tweet data and other internet sources in order to actually make the prediction, but we were unable to do that in time. But for future improvements, what we would do is collect external resources besides historical data like tweet data, news, sentiment analysis, and such. Any other questions?
Great job, guys.
Cool. Thank you. Let me go. I'm coming. Yeah, you be in the center, bro. You're the mentor. You be in the center.
Which one's to enter the streamer? What do you mean HDMI in the streamer? For Amen. I don't even know. I think we need to bring us to stage. I don't know how to do this.
Yeah, just go ahead and
Are we just doing HDMI? Mm-hmm. Oh, okay, cool. I thought they said earlier to enter the stream then.
Yeah. So you guys are conjured?
Yeah.
Alright, so click on present.
Use your presentation.
Probably 8 minutes. We can go faster for me.
You're just like, let's go ahead and present. So you're going to share screen.
Share screen.
Yeah. Just, you can click on the entire screen, please. Yeah, click on the. Should be to it.
All right, it's okay to go quicker than we practiced. All right, take it away.
We come here today to bring you Conjure, a program that generates abstract art. My name is Lemuel.
My name is Anthony, and this is our mentor Niven.
One innovation that's currently trending is AI art. Companies like OpenAI have created programs like DALL-E. You'll be able to create abstract art using methods like Stable Diffusion. But like a real artist, it takes many, many references in order to reproduce an image on your own. And as in the case for AI, that can take millions upon millions of images in order to train one model, which means that just training these takes a whole lot of resources. So our goal from this project, like many things, We took inspiration from nature, and in our case, we based our program off of evolution. And our goal from this project was try to create abstract art using less computing resources than what is usually used. And this program was mainly just to research new and creative ways we could create abstract art. And to do this, we created our own evolution simulator, which would take the images deemed the most artistic and mutate them over time. Our classification model, which would classify which images are considered more artistic. And in the end, we compared our results to the industry standard DC-CAN.
So we use an evolution simulator to evolve the images. So first, we randomly generated a bunch of images. Each image is an individual, and they have a lot of points which have certain properties such as size, color, location. And with each individual, we gave it a fitness score to measure how artistic it was. We'll get to that in a minute. But y'all heard of survival of the fittest, right? So like the top half that are the most artistic, they get reproduced and they're put into the next generation. And after 200 generations or so, as you can see, these images start to look a little more artistic. Now to create the scores, we use a classification model. And to create this model, we use a data set of 1,000 pieces of abstract art and 1,000 randomly generated images. This is very different from models, AI models you've seen to create other abstract art that take millions of images. And from there, we use that data set to train a convolutional neural network to classify the images. And so we use the following to create and host our model. We did it all in Python. If you all have any questions, we can answer them after the presentation.
These are the results from our first few iterations of our model. In the beginning, our model produced images that mainly contained white space. So we included some images that mostly contained white space in our data set. And we slowly gained better results, as you can see in iteration 2. And towards iterations 4 through 6, we started experimenting by changing the hyperparameters used in our program, like how many points can get added per mutation and the size of said points. When approaching 7 through 8, we started experimenting a bit with color, and you can see the results of that. And we didn't like the artistry of the results from last time. It seemed, our data set that we trained it on seemed under-centralized. So we gave our model a new data set that was comprised entirely of sunflowers, and these are the results. As you can see, it makes a tenth of a sunflower. It contains the green of the stem and the leaves, and the yellow of the petals. It even contains bits of blue because of the sky in the background. But as you can see, it doesn't exactly look like one.
Now, to test the model, we want to compare our newly built evolution model to a model that's already research already out there, a GAN model, in this case, a deep convolutional one. So this one, there's two models, a generative model and a discriminated model. The generative model's goal is to try to generate an image that fools the discriminated model and make it its actual art. Meanwhile, this discriminated model is trying to call the other model's bluff. And as time goes, each model trains the other model, and they get better, much better and better. As you can see, these images, they look a lot closer to art than our evolution model. However, the time computing used to take the model took a lot longer since with the GAN model, we had to use a GPU, and it took over 10 hours to create the model. Meanwhile, the evolutionary model, it only took 10 minutes to create the full classification model, and we only used a simple laptop. Now putting the sunflower set in, it's starting to look a lot closer to sunflowers if you zoomed it out enough. It'd be very hard to tell a photo from a sunflower. For one of these, you can see some sky, some grass, some petals, and maybe even, so for some of them, you can even see the center of it.
And here's a direct comparison between our evolutionary model and the industry standard DCCAN model. Both models were trained on the same set, but as you can see, our model has a ways to go before we compare with the likes of DCCAN. So, what we can conclude from this is that our evolutionary model did take far less resources. It took much less time to train, but however, it takes way longer to curate an image. And yes, both models took the same number of generations to create the images that you saw. And one thing we could change is that instead of sporadically placing dots on a blank canvas, we can mimic the camera quality that you may see, such as 1080p times 480p. No. Great. A better image for better results. And we can use more specific images to create what we might want to see. So our model still has a ways to go. However, we're hoping that with enough time and research, we can create a model that can actually create art. Thank you for your time. And we are open. We are open to any questions.
I enjoyed your presentation, and I think that there's value in learning what your model can do versus the industry standard. So I have a question for you, a challenge really. Can you think of circumstances or situation where your evolutionary model would do better than DCCAN? By better, I mean not only in output, but also, as you alluded to, resources consumed. I'll use an example from a completely different industry, the electric vehicle, right? Tesla seems to be a leader in this market, but will they remain a leader? That's unclear, because most of the world's population cannot afford to spend $40,000 to $60,000 on an electric vehicle, and electric vehicles are most needed in places where people do not even drive the kind of internal combustion engine cars we drive in the United States. They drive motorcycles, they drive mopeds, which are much more polluting than our internal combustion engine. So industry observers believe that the future of EV is not Tesla, but it's cheap, small, much less powerful, mopeds, motorcycles, or micro cars that can fit one or two persons in them. So resources are an important constraint in the real world. So is there a situation in which your lightweight evolutionary model will do better than the DCCAN and industry standard?
Our model would be more beneficially used on lower-end computers with lower-end GPUs and overall may work as efficiently and less fast.
Thank you.
Thank you, guys.
I think it's time for dinner, so.
You guys could head down like to that door.
Oh,
yeah, right. Yeah.
Everyone else.
Yeah, feel free to walk down that way.
There used to be 5.
Party tree. I mean, technically 6.
Thank you, guys.
Yeah.
In total, 10, right?
10, yeah.
Okay, yeah.
Yeah, sorry about that.
So the curriculum that you taught us is for my whole Amazon. It's machine learning versus library that's more focused on the utilizing what's going on. So there's where you're working on Yeah, so what I made to make sure you did like first initially it was like basic, like your end a little bit maybe like put it on the book. I didn't like wasted too much time explaining that the concept, which is good. I think we can't so why meet the professor? Let's get them to use like and make it pitch like it's like a startup or like a so their idea product solves the problem versus I'm just doing machine learning, right? I run like the Spotify one, the very last one. So I did that project for my machine learning class last semester. I was 2 days on AWS. That was like a 90 because I had it right. All I did was run AutoML and everything was code, right? That's not to say I was a coder. That's to say I just used my resources. Same year we just built a system here. The product is for your first data aggregation, processing your EDA, like sports data analysis. Go through like what your models are like most inventors have this yeah. So I think I make sure to hire people. So here's my like it's super application based. They find themselves in the students. And we take people with no issues, like no interviews, so we have to deal with some people who are a little bit struggling. And even if they're not perfect, sometimes we have to do like a poor number. Yeah, she didn't want to be a victim. She did learn a lot for the project. Like she felt that she needed anything. Right? In a normal like graduate level, this is normal. But she's right? So I had to push her. It's just leadership, making sure that they're invested in projects. And we don't even manage it that much. They just push. And they push a lot harder than my course. So are you judging for next week? Are you going to see the project next week?
Oh, you mean the exam?
Yeah.
I just see the invitation.
Yeah, so I do agree. Yeah, so I really want you to go take a look at. I just want to see what because we learn a lot from their program to our this one. Right? Because we're less structured. Like, again, no, I think. Do you think it's perfect? Okay, sure. Oh, Haven is. I have to there that it can be because the reason why I'm going right, I have this presentation so long, but I wanted to like there's like 3 to 5 minutes, but how can you encapsulate what I read? Can't. I think it's very good. I don't know what you can like inspire us to do this. So that's it. So this product level stuff, but they don't know that. Yeah. So, but this one project, right? So the people, so those 2 people, right? They're half of their team problem. So there are only 2 people. So that was the people I was most worried about. But Nevins is engineering. They work on something, right? Evolutionary is like one of those things. It's not something that's happening, And he made sure that those 2 people knew what they were doing, and they took it to the next level, right? And plus, we have no budget. Like I think you have no budget for anything. I think the first year I used it, I paid $500 out of my own pocket. Not just kidding, because one of our older vendors, he only just wants like 100 or 200 database.
What's the most complex project? He was supposed to be director, but well, I will say, well, remember, technically a nonprofit now, so we can say, right? But again, my like whole thing is, okay, like this whole project of all these. I forced 11 projects. Because this year was like the stretch, like it went from 8 to 11, or 16 to 11. Oh, wait, we had like 5 or 6. Like 5 or 6. So no, we've been doing AIM since 2021, but the AWS transformation didn't happen until 2022. So technically it's a year anniversary of that transition. Because I made sure, like, from my experience at AWS was teaching. And Emily was just brain dead using my personally. Watch the videos, it's YouTube. It's like 3-minute videos and it captures the attention. Right, next year we'll probably do more, but probably expand to 15. But again, the goal is expansion. We can take the Blackstone Launchpad. This time we don't have paper. I'd rather do some of my ML class where I need to get an A- into graduate. See, I struggle because I don't care about time. So he's straight. I mean, like, hopefully he serves, but I went to his office hours, like, during this thing. Like, I have Dr. Min for web programs, but I didn't do any of this. It's not even comparable because they sit on the mat and they sit on the plane, and which is good, but like, I think the closest is like not to it is or Rishab guy. Yeah, and my personal experience was it's a good class. I just don't like free class. I want to work. If you give me a project, you're gonna sound good. Like I have a project for time and it's due after exam. It's like SPM or something. I know with ChatGPT and the right automatic right? Right? So I think when it comes to math and stuff, professors will give it to the professor. So I don't know. There was a so like I'm not teaching them lasso, L1, regularization, any of that. But if they understand like the overview, so if I add this, it makes this impact. Like that's all they need to understand. And they use like 3 or 4 networks. The focus is it's more the only problem I think we had last year with Dr. Gonzalez. A lot of it's like rather than true AI. This year the first one you saw. He's very smart. He used to work at Meta. He only works on phase and NLP. He's been out like since the beginning of the and he's been working on this. Like he was gonna work on this for his UT project in Nuclear because no matter what, you're very competent team. But again, I don't know. It's not super sophisticated. It's obviously not, but that's okay. Right? I'm glad you're enjoying it. I had to offer, but it's the money thing and then also just like getting space. Like I had to rent out Blackstone like 10 times or just our office meetings to run Hackaday. I wish you would have came to Hackaday. Yeah. I already happened. It was the largest AI hackathon. How long or under?
I like this presentation requiring I say every that's
what was the rest presentation about? So is it like object detection over there?
Oh, here's an object detection. But I mean, probably like different semester also that I understand the impact of that. Like here you see like Emerson, it's full calculation about
yeah.
Again, some of them don't reach that, which is fine because they don't have experience. Right. Well, that's the key. Because this is that one project that I helped get. So you know Adam, you know Makerspace, right? The president of Makerspace indirectly gets job through me because of that one project I helped us run. And he was telling me like this one project, it was so simple. It was just style transfer. Right? At the time, style transfer like 2021 is like super cool. Now it's like 2 seconds, right? And now it's stable diffusion. How am I prompting it correctly? Right? And I look at the MIT lectures for deep learning, like we're still behind. Like as a university, we're still behind. Yes. Yeah, we can go get it. I'm just
Sorry, I just like before they talk.
Hey, did everybody get pizza? Easy.
Yeah, I
You just said that. You said that. Dude, I wish I could show these things, get exemptions from all my fucking work. I hate school. I want to get the hell out of here.
That's how we get back on. That's what you're
Yeah, we should do that.
It's just that all of our projects. Yeah, y'all don't actually know what y'all are working at. So they have that teaches for television. Sorry, I think you're trying I feel like my wrist is not that bad. It is. He said that. And you can on my ass. Where's Neil? Neil! Yeah, bro, you see this? He said it was a good Okay, I thought it was. Sorry. Oh, that's okay. I mean, well, yeah. You guys are acting out. No, yeah. I don't know, I'd like to suggest referring to Chairman Rankin. I think it probably be the research lab. Well, it's like I like the presentation.
Things that one can study or to get more entertaining presentations. Like less visual or more visuals and less bullet points.
Yeah.
That's okay.
Yeah. We call it the size of it. The size of the. Presentation, I didn't have to mic, I didn't micro it, so. Did everybody elevate it? And all this is now. So. I would say like in person, it's already some. Yeah, in person. Yeah, I checked that. What was that? No, we were like, at least I keep it posted. College. I'm talking about college. I'm talking about like.
So I saw there's one
It's like in Vegas first. But that's not a good word. You said university, yeah. I don't give you right. I would say largest student. I'm really calm. You look. Maybe next year. But I won't. Already asked. Any questions you basically understand? I'll be description. I'm working projects covered. Good. It was 300 people. I'll show you the demos. We had an issue with it because there were so many good projects. I wish I could do Gen AI stuff. That's okay. Do you guys have the curriculum still? I'll send it. Yeah, if you can send it to me, then we might just teach it here for your kids. So this year we had 100 students. Those out of those 50 products, which is a 5 year, only we get like, but this number we're striking at 15. So it's like, we thought, okay, it's been a while. goals that were very because there's one I have to say. So this way. But it would be only the same as AI. That's what this one was It's really cool to see this, right? It makes up all this. This is just some of the. Yeah, the number of. Yeah, that's some wrong. I'm sure that's. There's a guy out there. It's not. The issue is that always the products are so large. Even the actual. So this is one I got first place. Yeah, so there I was top and get this so really funny about this is like somebody like a long Friday before that and maybe my dad was but he was a judge. So they take the right essentially they use all the information you need to write. So it writes a sample plan using ChatGPT. They they've been having fun with it ever since this project shows you so I think the 6 is going to come in all of those guys and see what happens to interaction, analyze that. So so we brought in something called Resto. It's a company that's white funded that starts stuff. They only released 2 weeks before that. So I feel about that for but no code. No code, just like this. For full automation, just runs this stuff. So there was a guy King that was this is the other trend. This is the trend. They put no code everywhere. And these are something. It's like they get through that they get ChatGPT. So everybody, there's another one that was really funny called OpenRiz. My dad wanted to be first, but I think but essentially it tells you instead of the date with the oxygen, it tells you what to do. And it tells you what age you're going to all 3 steps. So you take this over. No, it just tells you how to talk to a person. So they use OpenRiz, and like it's just like how do you start the conversation. Some people it's helpful. Only 1 or 2 were like no code apps. Like oh, I don't know how to code, right? This one is Yeah, so he's created AI. They start. So this is a resource. It's something with knowledge. Right, and then this one is dry bar. I wish I could. But we have like usually, yeah, no, they said it late, so. So they have like access to yeah, this one was they actually went and played basketball. So they use Stable Diffusion Creator for audio. So they augmented with Stable Diffusion, which I think is a trend. And they, I don't know who's supposed to do that, it's a really smart idea. So it's kind of synthetic. Actually, you all think about the first right, and first and color, exactly. Stable Diffusion Creator, I don't know if that's. Actually, like, canvas color. It's new types. And also yeah. This one is oh wait, they use now, so they basically they all Hey, Dad, do you have your presentation for the IntelliFringe? Yes. Can you bring that over here? It doesn't work right now, but it doesn't need to work. I just want to see the presentation and the restyle. Restyle? I don't have restyle online. Can you take a screenshot of it? We did pretty much. That's fine. I just want to see the screenshot. There was also another one called True Pilot. This one are ethics because yes, it tells you what's reasonable about it. It tells you what's so it tells you all those modifiers. Oh, where is the official claims? It tells you where based off of the hate speech, right? So it tells you what's going on. So I get I guess I get for 24 hours, it's all good enough. So I went through every presentation and problem solution.
I guess we'll see here when you're finished presenting. Not yet.
Next on business. It used to be able to do API calls. So we can call.
Yeah. Oh, wow, that's not good, yeah.
Yes, this time we should. Are you going first or do you go first? No. You want to take over? There you go.
We didn't see it. How do you find that out? Right. How do you know 8? How do you find that out? Oh,
Hey, everybody! We need everybody inside right now, please. Please start making your way in. Next presentation, please get set up.
Okay, yeah.
I'm going home.
Where should we stand?
I was told you guys stand over there on the left, but honestly, I don't think it matters too much.
I don't think it matters, yeah.
hmm But I mean, you guys should probably all stand to one side, probably.
Probably,
Just because, I'm only going to talk for like 1 second, and then you guys are going to go.
You should start with something to do first person. Yes.
Oh, okay, I see myself in the camera.
No. I just received the email. Yeah, I'm a professor, assistant professor. What do you teach? Computer vision and also VR. For me, it's AI.
Switch up the presentation. Sort of. Okay, if you don't want to, it's fine. I'll feel bad now. Okay, yeah, keep going. Power through.
There's big difference. You see, right? How to fix it up after every center. You can even test. You can drop the computer. No, you can see. Combining the motion. Yeah, how can you learn that? So for that, everything's structured and we talk to this construction isolate stuff and combine better. There's so many diverse, so much information. It's not that just a model thing. Items and entities like language. Yeah, so that's a change. Farming complicated. I think this is true. The original situation.
How can you see it? Yes, Brian? Yeah. Real quick, can I just?
I think streaming for almost 3 hours.
That's a real joke. That's a real joke. Very well. I'm too now.
Yeah, he lives there. And he regularly frequents a lot of them.
Someone's perspective.
Yeah.
But you can see the real maps like studying stuff, generation stuff, and also recreating stuff.
Yeah, it's like a good
Hi everyone, I hope you guys all enjoyed dinner. We're gonna get started back again on presentations real quick. Just for the remaining groups, just so we can be mindful of the judges' time, because we're going a little bit over. Just try to speed things up a little bit. If you got like any details that might not be necessary, just kind of leave them and just try to speed things up. So thank you guys.
All right, so hello everyone, my name is Bryant and I'm going to introduce our project Paintify, a tool to turn your doodles into artwork. And here's a cool quote, but you guys can look at it if you want to. We'll just speed it up. So I'll let the team introduce themselves. So,
my name is Rohit, I am a junior and a CS student.
My name is Nicole, and I'm a freshman CS major.
My name is Srinish, and I'm a sophomore SE major.
My name is Tony, and I am a freshman CS major.
So the key topics that we will be discussing in this presentation are our mission, classification model, control net diffusion model, and the impact and future of AI art. So oftentimes, people have these creative ideas that they want to transform into art, but simply don't have the skills, time, and resources to do it. So our mission is to make people's creative vision come to reality by transforming their ideas into full-fledged art. So we use AI and machine learning to transform simple sketch drawings along with descriptors into full-fledged paintings. The main stages of our project are classification, stable diffusion, and front-end GUI.
First, on Paintify, the user draws a simple sketch on the canvas. The classification model then classifies the object by generating the predicted label of the drawing. The Stable Diffusion then creates the resulting image from the label as well as the text prompt.
So the classification model. The first step is to have a data set. And luckily for us, Google had a data set of sketches that had 15 million drawings. Unlucky for us, being broke scholar students, we don't have the time or the funding to process this many data. So as a group, we decided to sample about 200,000 images. So classification. So we used Jupyter, an AWS app that implemented a Keras API, which uses an open library of Python called TensorFlow. So how this works, we create a CNN model which specializes in images. And how this model works is it takes in the data, splits it up into layers, reads in the data points, and understands how it relates to each other. And once this model was created, it was trained multiple times with epochs of multiple batches. And after we finished the model, it was about 72% accurate, which we were happy with considering how small our data set was. And as you can see, we've added a picture of a tree, and it was 93% sure that it was in fact a tree. So not bad.
So once our classification model had successfully predicted the text label of the image, we would actually use that label plus an additional text prompt to put that into a Stable Diffusion model. A Stable Diffusion model basically generates images based on a text prompt. To allow further control, we also incorporated ControlNet, which would allow the initial image input drawing itself to pass in as a parameter to the ControlNet model, which would then allow the generated image to take the shape of the our initial canvas drawing.
For our front end, the vehicle we chose was React.js because it's one of the best frameworks for creating functional websites. As you can see, we aimed for a very simple layout. We added animations using keyframes and CSS and also an external library for the typing effect. We also added a color palette and a variety of buttons that work well with our canvas.
So the front end, as mentioned, was made with React.js. And we basically call our model, which is made with TensorFlow and switch it on AWS. We use API Gateway and Lambda to make calls to our model. And then we also make a subsequent call to Stable Diffusion model using the text signal that we got from the original model plus an additional text prompt.
Overall, we use AWS, Visual Studios, and TensorFlow for the majority of our project. For the sake of time, I won't go too into detail, but we had a lot of difficulties along the way, mostly technical. And in order to combat that, we made sure to get as much done in the first several weeks, and then at the end, make that time to fix those errors that were popping up everywhere.
And now here's our demo. So these are some things that you can, so here are some things that you can draw. So drums, the sun, candles, baseball bats. So I'm gonna draw something simple. I'm gonna draw a sun. So now when you hit the submit button, you should see two images at the bottom that are related to the image. The classification model classifies it as a sun, and the confidence level is almost 1, which is really good. So here's the first image. And then the second image is supposed to show up. There's two settings over here. We have the strength and the guidance scale. If we increase the strength, the prompt will have a greater influence on the image. And if we increase the guidance scale, the script will have a greater influence on the image. I'm going to adjust it to the full settings. And you can also override the prompt for better results. So you'll see two new images. Of course, the second image doesn't show up. And that's the demo.
And for anyone that would like to give it a go, there's a QR code.
You can test on your phone.
Yeah, it's really nice project. I was surprised about the final results I can see. So, which part in your framework, which model is responsible to combining the scratch provided by user and to the final output?
So the images drawn on the front end are basically pre-processed using a library called cake.js. And then we're basically pre-processing those images down to 28 by 28 size, and we're also grayscaling those images. And then we're basically we're calling our model, which is on AWS, using AWS API Gateway and Lambda, passing the image data from our canvas to classify the actual image.
I see. And then you get the prompt, and they just give the prompt to the stability viewer and then generate.
Yes, the prompt is set by us.
I see. And there's a type of model which is called personalized generative model. Probably you can search like personalized stability viewer and stuff. It can like better combining the certain input provided by user and to generate the custom picture. Because for the stability viewer, you give the text, or everyone give the text, it just generate the same output. But you probably have certain preference. For example, you generate certain I want to put a kid to a beach, but I just only want to put my own cat to the beach. So then there's certain custom user appearance can be provided by using personalized model. So probably you can further consider to combining that kind of model and to enrich the user appearance and let them be more happy to interact with their model and more personalized with certain things that they can put. But anyway, very nice project.
Thank you.
Devin, did you have a question?
Yeah, I was going to ask, do you guys train your own stable diffusion model, or do you use one that's already out there?
We use the one that was already out there, and
yeah, you spend like a couple million too.
So in the culmination of the challenges that you faced, I'm curious about the process. What have you learned about the process of software engineering? If there were a team today here that's just about to start their project, what advice could you give?
The one thing I learned is there's a lot of resources out there. This is my first time ever working with Python, ever working with AI stuff, and the idea was that we just had to develop it. We had to set the steps that we needed to take, which was this classification, stable diffusion, and then after that we just had to use the resources that was out there on the web, and it made the most of the process really, I wouldn't say easy because we put in a lot of work, but it helped me understand a lot. There's a lot of resources out there that helped.
So by resources, you mean you had to teach yourself a lot of skills?
Yeah, there was a teaching, and there was also a lot of tutorials that, so very first thing our mentor did was he assigned us this tutorial that was kind of like a baseline of what we did, but way simpler. And doing that, it was like code for code. I didn't actually have to code anything, but doing that project helped me understand what our final project was gonna look like.
Very nice.
You guys can go. Picture. Oh. Oh, can you do a stream on that shit? Oh, really? Yeah. So it's the HTML and the stream. Oh, is it a senior? Yeah. Just use it. You don't have to turn it on. Click on present. You share screen. Share screen. You can click entire screen. Yeah. Yeah. It doesn't work. Oh, plug in HDMI. Once it's okay. Okay. So, okay. Okay, you do the whole thing. I will just be ready.
So hey everyone, our project is a basketball highlight classifier. I'll go ahead and introduce ourselves. So we couldn't have accomplished this project without the help of our mentor, Dan. Yeah. And I'm Andre, I'm a sophomore CS major.
I'm Adorable, I'm a sophomore CS major as well.
I'm Rishal, I'm also a sophomore CS major too.
So what are our problems/objectives? So our problem is that basketball clips are manually classified based on their categorical statistic. And our group has implemented AI, specifically computer vision, to overcome this problem of manual work. So through AI, we were able to pre-process our data. In this case, approximately 10-second NBA clips through web scraping for machine learning model training with the use of 3 models, YOLO v5, MoonNet, and scikit-learn. And from the use of these models, we were able to evaluate each model's performance. Now I'll pass it on to Eduardo, who will talk more about our data collection.
So this is a pretty good idea of how we went about collecting our data. So we started off with web scraping using Selenium, and then we pre-processed our data using the OpenCV library. And then we took that pre-processed data and we put it into the YOLO v5 model. And then after that, we basically post-processed it after that. So a little bit more about the web scraping. So like I said, we use Selenium. So our data is NBA video clips from the official NBA.com. And Selenium is basically a web scraping library that allows for the automation of processes, downloading video clips. And it was really important to use Selenium in this project to make sure that there's enough accurate data and enough in the data set as well. And we had a lot of challenges with our web scraping at first, especially because with our Python code, some of the URLs didn't give us video data. And so the solution to that was using older seasons for our web scraping, which helped us. And then another challenge we had was in our project, our categories include like blocks, steals, assists, turnovers, etc. And we made our categories have turnovers and steals be separate, but on NBA.com, steals are considered turnovers. And so in our Python code for web scraping, we actually had to implement a filter that basically said that if it's a steal, then it's not a turnover. And that presented a little bit of a challenge because when you run our turnover URL data, sometimes it wouldn't give us enough data. So just doing that over and over again with repetition was really important. So with the OpenCV library, this is where we did our pre-processing. And so the main idea of this is basically to take the video clip and basically extract the frame from the video. So take like the 8-second video clip and extract the 1 frame from the video that's necessary to put into the YOLO V5 model. And OpenCV is important for 2 of our models that we use out of the 3 because it basically helps create the data that's used for the next model. And so it's used in the MoveNet, as we'll talk about later as well. And with the MoveNet, it's also important with like drawing, obtaining coordinates from various parts of the body as well. So the YOLO V5 model, essentially what it is, it's a very powerful object detection model that can recognize a wide range of objects and videos through recognizing specific events in the clip. And we trained our YOLO V5 model on 980 labels in the dataset. And it was important for basically detecting the objects in the pre-processed data.
So after we use YOLO V5 models to extract the frame and identify the players, we also continue with the MoveNet model from TensorFlow and the scikit-learn model. And what you see right here, or what you saw on that pyramid, was our entire tech stack. So for the MoveNet model, we used it for the human pose estimation, and it was trained with 40,000 videos. As for the architecture, we use the feature extraction backbone, which is comprised of 2 branches, the pose classification branch and the regression branch. The pose classification branch takes in the landmark coordinates of the players based on the cropped images outputted by OpenCV and YOLO V5. And these coordinates are placed on major joints of the players and like the heads. And this branch outputs a feature vector with the coordinate information, which is then passed on to the regression branch. And the regression branch is kind of like performs a lot of operations and calculations that it's kind of hidden away from us. But what this branch does is it outputs a prediction of which pose class these players are in, I guess. And there are 9 pose classes that each player could possibly be in. And that's when the player has a ball in the hand, when the player is blocking, when they're trying to defend, when they're dribbling, when they're not doing anything, no action, when they're passing, picking, running, shooting, and just walking.
Where do these poses come from? They emerge from the data, or you designate them?
We designated them. It's just these are just the poses we're looking for, and it helps us identify what type of highlights. We'll talk about that when we get to the scikit-learn model. And some of the issues we came across when using this model is that this model tended to skip poses when there are multiple players in the frame, or if a frame was kind of blurry or something like that. And this issue could have possibly come up when OpenCV was extracting the frame, or just with like player formations in the middle of the game, which is something that's out of our control. So next, we pass this information onto the scikit-learn model. We use the scikit-learn model to identify the class of the video as a whole. And we use the pose information from the previous model to calculate that. So this model was trained with 50 videos for each of the 6 classes that we're identifying for. If a highlight, and these classes are if a highlight was a miss, assist, steal, block, turnover, or rebound. So we use a total of 300 videos for the data set for this model. And As for the scikit-learn model, we use a random forest classifier algorithm. And how this basically works is that it creates multiple decision trees with random subsets of the entire data set to come up with an accurate conclusion, I guess. And this also reduces the risk of overfitting because of just how many decision trees there are.
And now we'll move on to our demo.
Just do a live demo right now.
Oh, I'll just do it later. Okay, so I'll do a live demo, so I'll go ahead and. Okay, so this clip should show a rebound. Okay, yeah. So I'll go ahead and copy and paste the link to our. Yeah, so we'll go ahead and run it. Okay, so one important line would be line 18. That's just a line for our YOLO v5 model, which does it's just an object detection algorithm on the extracted frames to detect and crop out basketball players, and these images are stored into a folder. So yeah, each row represents an image of the cropped out player. And here we can see MoveNet working. Just taking
almost there, 13 seconds.
Yeah.
10 seconds.
Yeah,
Nice. Almost there.
And our output is steel, the confidence of 0.24. So our future plans or developments, we plan to increase the data set. For higher accuracy and implement audio for our model as an additional or better way to classify our clips efficiently. And we also plan to develop a front-end user interface and perhaps also take in longer videos such as entire games or quarters. And that's our presentation. Any questions?
Nice. So so for the class, how many classes do you have?
So for the MoveNet model, we had 9 classes, post classes, and as I mentioned before, each of these post classes represented what a player was doing at any given time. So we were tracking whether like a player had a ball in their hand, whether they're blocking someone, if they're defending, if they're dribbling, if they're not doing anything.
Yeah, I think it's a very interesting project. And besides this, basketball is a group sport, right? So there's the group activity. So while people is preparing for shooting, and there are also other people, like other persons are happy with this shooting. So rather than just like individually to predict the post, that would be even more interesting to know like the relation. Like for example, there's a person is shooting and the other what a relation like how other people can help with this person. and to know the group activity on this like whole thing. That would be very interesting to further enhance this project. But anyway, it's out of scope of current project, but it will be interesting to do this in the future.
Right, that would be an interesting future plan. Just gets team synergy.
Yeah, nice project. Yeah, well done.
Thank you. Any other questions?
Strikes me as a really difficult problem to solve because of all the reasons you mentioned. So if you're able to have some success in this project, staying with the theme of sports, if I would provide you clips of swimmers and ask you to predict what is the swimming style, the backstroke, is it chest, etc., it should be much easier to classify, right? As much as interference from other players, the movement are much clearer.
Right, I agree, especially since the tech stack we used with YOLO v5 and MoveNet and scikit-learn, it's really easy to classify and sort what type of shapes people are doing with their bodies, and I guess it would be more applicable to swimming in some sports like swimming than others. So I agree, yeah. I think this technology could be applied to a wide variety and range of sports.
Because it's a small model, so we don't have enough resource money to do like a big model. So we only use like we use a TF5 model and a Euro 5 small. That's it. Not like the bigger model. Bigger model will cost more money to run.
I can add something like YOLO is kind of an end-to-end model. If you take one to the recent talking though, there are a branch of models which are two stages, but they are accurate but very slow. So I think YOLO is kind of like a balance, like trade-off between performance and speed.
Okay, so I got a couple of questions. The videos for movement, are they broken down into pictures? When you like trying to analyze them? That's my first question. Second question, you said the future wants to implement audio. How would that be relevant, or how would you guys implement that?
Right, I can answer the MoveNet question for sure. So what OpenCV does at the very beginning when we're collecting and processing the data is that we take frames from the data and then we crop into them in the data processing part. So MoveNet's really processing a still frame instead of video as a whole, because that would be really intensive, resource intensive. As for the other question,
Then as for the audio, you said how it would be used, or?
Yeah, how would you implement audio?
We don't know about that, but maybe we could use audio just for like telling like what are the like best moments of a game or like the most heated moments. Which will really just attract fans.
Yeah, for example, in a whole like recording, it can be very loud for this recording. That would just like if we make one short video, and probably we just need a few moments, and then audio can help. Why? If there's the excellent moments, and you can hear cut sounds, and then audio can help here. Yeah, it would be helpful to help you detect certain very exciting moments in sports, and then you can compose them into short highlights, and that's kind of like application.
Any more questions? Okay, if not, then I guess it's all.
Good job.
Guys, can I get a picture?
Pictures.
Great, thank you.
Others,
nonprofit
Thank you. Thank you. Thank you. Well done. This was impressive.
Guys. Okay, so get a connection to HDMI over there. I don't have an HDMI adapter. Hey, does anyone have a HDMI adapter for like a MacBook? Borrow. You know. MacBook to like a USB-C to HDMI. Oh, thank you.
Yay.
Cool. Thank you. Yeah, so go ahead and then join the stream.
You guys will be on. So you guys will stand. So Crunchups will be on this side.
Just put something clean in. You don't have to be.
Yeah.
You don't have to have your
So
camera on.
Connor will be between y'all two.
Yes, okay. Enter studio. Oh, you can mute yourself. And click on present right there. Share screen. And then you just do entire screen usage. I have to. It's gonna make me go in. Oh, all right. Let's just go and do that.
Commercials are the biggest right now. Commercial small business. So that's a big. We have a technology and that's what these students are doing. For software engineering, cybersecurity. Let's do it. I'll get a good insurance. Yeah.
Yeah, for entire screen. Those are good to go.
Hello, everyone. My name is Tejaswan. I'm here with my fellow mentees, Connor and Piyush, as well as our amazing mentor, Raven, and we'd like to introduce to you Chess Vision. Hello? Can you guys hear me?
Yeah.
Okay. My name is Tejaswan. I'm here with my fellow mentees, Piyush and Connor, as well as our amazing mentor, Raven, and we'd love to introduce to you our application, Chess Vision. So some of you may recognize this match if you're into chess. This is Grandmaster Magnus Carlsen going up against Jordan Van Vries. And this match happened a short while ago, well actually a couple years ago. But it ended in a draw, and it was actually pretty amazing to see these two go against each other. And this right here is the game uploaded into chess.com. And if you can see to the right over here, this is a full analysis of the entire game. Now, most of this is white, but you can see some spots in red where both of these players created blunders. And all of this isn't created by any kind of person. This is actually created by an AI. Now, for years, AI has been much better than people at chess. That computers overtook us at chess quite a long time ago, back in the 90s. But ever since then, they've been able to give us an amazing analysis. Now, the way that we actually upload all that kind of chess data up to websites like chess.com that can give analysis like this and places like Lichess is through really expensive boards that can cost from $600 or it can lowball it to $300. But for some smaller applications, this doesn't really work out. For example, let's go to schools. Right after the pandemic, I was part of a chess club in my high school. And they could have up to 10 tournaments at a time. And this is the same conditions that happen across the nation. Sometimes they have like 50 games going on at the same time. Now, if we even go with 10 of those boards, along with lowballing it to $300, that's around $3K. And I don't know about you, but those clubs can't really afford that. This is where Chess Vision comes in. And its purpose is to take in an input, similar to how you might scan documents when you're submitting assignments on your phone, and turn them into PDFs. You do something similar. You would take an image of a chessboard and you would input it into the program, and you get an output, which would be a full analysis of that chess game. Who could win, a prediction of it, as well as any kind of blunders that you might have, and any other kind of information that you get from Lichess or Chess.com. And the way that would work is that it takes in the image, runs a model, evaluates it, and gives any kind of analysis that you might need. And now I'll pass it off to Colin.
Hi, so our first model was piece detection. So we needed a way to determine what pieces were on the board. So we trained 2 models for this, but the data set includes 1,000 chess pieces that we found online. So most images came from Google, 2D and 3D images alike, and we kept them in S3 buckets on AWS. So our first model is Fast RCNN. We trained this through SageMaker, through a Jupyter Notebook, on AWS. Essentially, we pulled our data set and then pulled a pre-trained model from ResNet, and we ran FastRCNN on our data set to build our first piece detection model. And I'll hand it to Piyush so he can explain his YOLO V5 model to you as well.
So the first model I trained used YOLO V5, and YOLO stands for you only look once. So basically how it works is it runs the image through a single neural network, and it predicts the bounding boxes as shown in the image, and predicts depending on their weighted probability, and it makes a propagation run through the model only once, so it ensures that each object is identified only once. So the first model I trained was trained on Google Colab, and it was trained on a Jupyter Notebook, and we got an accuracy of 91.3, but we were not satisfied with the results because the model, it was biased towards images. The dataset contained images with the same background chessboard, and so we were not able to detect pieces with a different background. So me and Connor, we created our own dataset, and we split those images individually, and Tejas was the one who annotated upon those images, upon each of those images. And for the final model, we were able to achieve an accuracy of 95%, and that was the one that was used. Off to Connor for the board digitalization.
So one of our most important parts of the application is board digitization. We need to take a physical board and then convert it into a digital one. So if you can go to the next slide, please. So we start with a taken image, and our implementation requires that we resize that image into something the model can use. After which we split the image into 64 segments. We were kind of debating how we were going to do this the first couple of weeks. We ultimately decided that the best way for our model to run was piece by piece on the chessboard. So for every image, of which there are 64, each image represents a spot on the board. So starting from top left to the bottom right. And our model runs on all those images, and then the results of those images are appended to an array. So if it was to run on one image with a rook on it, our model will determine, hey, this square is a rook, and it runs 64 times sequentially, pushes the results to an array. And after that, we convert that array to a string called an FEN, which is something a lot of chess engines use to print out or evaluate chessboards digitally. So we get an FEN string, we send it to our application, it converts it from an FEN to an actual image, and then we evaluate upon that image as well as the FEN string. And I will pass it back to Tejas for obstacles in the future.
So one of the main obstacles that we had was time. So time-wise, we could have organized things a little better with our group. We had some obstacles here and there. There were things like the winter storm, happy eye, and the fact that none of us were taking the same classes. So coordinating the entire group to meet at the same time is a little annoying. And aside from that fact, we didn't really save time at the very end for proper debugging and actually getting different components to work with each other. So that was one of our fallacies.
One of the major obstacles we had was inaccuracies. So as I mentioned before, we were not able to detect pieces which were on different types of chessboard backgrounds, and we were not able to detect like different kinds of chess pieces as well, and that was one of the major issues we faced.
Our third and final obstacle was implementation. So as mentioned previously, our first two models, the yellow model as well as the fast RCMN model, their accuracy was high, but running it on the images that we created for the chessboard, for whatever reason, the accuracy, our accuracy was high, but for whatever reason, the model running on the images just didn't work. So unfortunately, we decided to go a different route for creating our demo today. Our implementation includes taking an image of a chessboard and then resizing it to fit a certain image size, and then running the RoboFlow API on those images instead of running our model locally on our machine. I'm sorry. The RoboFlow API is something we hook into for running our data set over the web, and that's what we'll show for you today.
So what's next for Chess Fusion is we could have implemented a proper tech stack, meaning like a front end and a back end instead of running a Python GUI script. And we wanted to deploy the endpoints of our application to AWS instead of Google Colab.
So one of the features that we want to implement in the very near future is cheat detection. And this is pretty exciting because, like I said before, AI eclipsed humans a long time ago in chess. So cheating has become a bit of an issue, to even the point that Elon is going on Twitter and starting rumors about people cheating and whatnot. And when you're getting on something like chess.com, you want to go and play with people and you want to actually see if you can outmaneuver them. If you play against a computer, it's not really as fun. And cheat detection is actually an incredibly hard task because just finding the kind of data for that is hard enough. No one's going to come out and say, oh, I'm cheating. And even if they do, who's going to play with them? So cheat detection is a pretty large task, and it was one of the things that we plan to implement in the near future, and we plan on getting over those challenges.
So we want to run evaluation locally. As I mentioned before, currently we pass our data set to RoboFlow. It runs a small YOLO model on our data set currently. Evaluation is something we want to do in-house. Ideally, when we started, we wanted to run evaluation in AWS with our data set, but due to time constraints, we have to use RoboFlow instead. So evaluation in-house is part of our next steps coming up. And I will show you the demo today. So, actually, can I have the mic back real quick? Thank you. So we developed a GUI in Python, and I'll run it from the terminal here. I'm going to browse for an image. Chessboard.jpg is an image we took a couple days ago, and it's the best for displaying what our models can do. So I'll hit go here, and you'll see this folder will populate with those 64 images I mentioned earlier, and our model will run on each of these. So once the model runs, it fetches the class and inputs it into an array. And you'll see in a second here, here's the resizing, splitting the image. Now it's sending the model to RoboFlow, and we're waiting on a response back. So once that comes back through, we will have the full chessboard printed, as well as the current evaluation for that board. And my internet connection in this hall has not been great, so it's taking a little longer than it should. Okay, so here is the board, the digitized board it fetched from the image. And these are our evaluations. So it's printing the best move, the top 3 best moves, and then a current evaluation of the board. You'll notice that this doesn't maybe look correct. The evaluation API, we're not sure why, but it seems to not be working with this image in particular. But yeah, this is our demo.
So does anyone have any questions?
So, very, very nice application. I see the need and you sold it very elegantly. The bad news is that all fun games are going to disappear with these kind of systems, right? And it sounds like much of the challenge was in taking pictures, right, and classifying the pictures. So if you think of a more standardized, like a card game, think about blackjack or poker, much easier to classify the images and much easier to make predictions since it's all about statistical probabilities. You can easily put casinos out of business just by having a tiny camera that constantly look at the cards that you hold and whispers in your ear whether you should fold or raise or stay in the game. Much easier application than what you did. I wasn't clear as to where the recommendations come from. The ones that you hope to run locally. Where do they currently come from?
The evaluations on the chessboard. Test. Okay, so the evaluations currently hook into something called, the application was Stockfish. Yes. So one of the most popular chess engines out there is Stockfish. The name just escaped me briefly. But currently we hook into Stockfish. I have the engine local on my machine. It does the evaluations that way. So it compares our FEN string, it plugs it into the Stockfish engine, and it spits out evaluations that way. A lot of it's under the hood. Thankfully, we didn't have to mess with too much of it.
And Stockfish just does only chess?
Yeah, it's specifically a chess engine. So I have it local on my computer. It basically plugs in the FEN string we got from our program into that engine and then prints out evaluations that way.
Yeah. It seems easily expandable to other games.
I would say so, yeah, most likely.
Because most games are simpler than chess, with the exception of Go.
Right, and then
If you think about most board games.
yeah, that's true. That's definitely true. Like on simpler games, this would be probably very effective.
Yeah.
I mean, as you mentioned in the casino as well, running this in the casino, you probably get kicked out pretty quick.
Yeah, absolutely. But with technology, it's become more and more difficult to detect cheaters.
Yeah. Right. Any other questions?
I think that's it.
Installing your glasses for
And a picture. Should we do this?
Yeah, just AR glass. They have camera and they are also like they use the drones like everything is like combined with this camera.
Let's not go to the same casino every evening.
What's guys? So you just gotta plug it in and join the studio. Sorry. Yeah, I'll send that to you now. Yeah, just click allow. Okay, oh, you click the button. Click collaborate. Just put some name. Doesn't really matter. And then enter the studio. And click on. Can you hide the taskbar? There's supposed to be a button that says. So it's usually like one like this is percent like right there, but it's like hiding right there.
Oh yeah.
Yeah. So click percent. Share screen. Share screen. Click on entire screen. Click on that little thing and then click share. And then plug in your so yeah. And then once it comes up on just give it a second. Should come up. But once it does,
Yep. All right. Sure.
Okay, good evening, everybody. First, let me introduce my team. This is our mentor, Edwin, and this is Daniel, and I'm Hudson. And before our presentation, I would like everybody to think about a situation. Just imagine you are talking with someone. You have a really good conversation. You think you have a really good conversation with that guy, and you feel both of us are relaxed. But actually not. That guy feels very nervous and embarrassed. But you still think he is pretty comfortable talk with you. You didn't notice that. Okay, so it's embarrassing situation, right? So we made this artificial intelligence, which could easily recognize emotion from human. Sounds wonderful, right? And also, we want the artificial intelligence maybe learn the emotion from human. That's our thinking. I mean, maybe. Because artificial intelligence don't know the feelings and don't know what is emotion. So we want them to learn, to know about emotion from humans. Okay, first let's talk about what are emotions. Basically, I think we could say emotions like happy, sad, disgust, maybe happiness, right? And what are the benefits? Maybe, improve the communication, better decision making, and so on. So a lot of things, lots of benefit, right? But how can we recognize people's emotion? If you want to recognize people's emotion, you probably will look at their face, right? To see their face, you want to know they are laughing, they're feeling well, right? But how do you need to, you don't need to look at their face, and then you will know their emotion. Then you need our emotion GPT. So, what is emotion GPT? It's an artificial intelligence application that will help you to recognize emotion only by their speech. Okay, so, but why do we choose the emotion GPT? First, it is a comprehensive tool. It means that the emotion GPT can easily recognize maybe 5 or 6 kinds of emotion, include happy, sad, disgust, or just happiness. And also, the emotion GPT can be used in lots of areas. It can be solved lots of problems, like maybe in the criminology, in the psychology, or maybe for the mental health, right? And also the emotion GPT, it is quickly answer the question, so it save a lot of time. And also the emotion GPT, it's a data security tool. It means that it will protect the data from the user and give the result.
So the components that we used for Emotion GPT is for the front end, we used Flask and React. This was to get the audio input and then pass it to our backend, and then eventually it would help get the emotion from the backend and print it out. So for our backend, we primarily use TensorFlow and PyTorch to do a lot of the analyzing and generation of the model. We also use Hugging Face for another pre-trained model, and then we got our data set from Kaggle. So how does it work? As I kind of just explained, it gets the audio and it puts it into it passes it into the AI, and then eventually it'll pass out the emotion from that. So the way this works is that we have 2 models within our backend. So the first one utilizes a lot of the spectrogram, and what this is, it essentially analyzes the audio and kind of presents it in this graphical sort of way. The other one was the Hugging Face pre-trained model. So what this one does is it takes the speech that we have and it turns it into a text, and then it analyzes that text for various emotions. If you have happy words, it'll probably be more likely to predict happy. So a little more into the spectrogram one, it's going to convert the audio to a spectrogram, and then it's going to pass that into our convolutional neural network. This works particularly well for images, so it ended up working pretty well for our particular data set, and then it will output whatever emotion it thinks is most likely.
Sorry, just to verify, it is trained on words or it trained on?
No, so we had a data set of audio, and it would train off of that audio, but we had one model that converted that audio to words, and then it would try to predict the emotion off of that, and then our other model would convert it to a spectrogram and then train off of that.
So you don't use tone data?
No. So the accuracy we achieved is in the end, the testing accuracy was about 92%, which is pretty good based off the data set that we had.
Okay, let's try Motion GPT. And this is our product, and this is the home page actually. And it's the about part, which include our fees, like those missions, values, team members, and now the exciting part. We can upload a file, or we just start recording.
So let's look at one file. Let's look at angry. If someone is angry, how it
It is
sound?
kind of like profession, like recorder, they record stuff.
There's no sound.
Why there's no sound?
Can you come this? I apologize.
Are you streaming through the stream deck thing? If so, you have to include sound. You have to like exit out and include sound.
You might
So
just,
it's like, you should just be there. You have to like
you might just show it.
That's one.
You might just show the upload the file.
Yes. Let's upload. Yeah. I remember.
Where's the mic? Like where's the
Yeah, it's over here.
over here?
Wait. Can you guys hear it? Where's
Again? Yeah.
It's a little bit horrible, but can everybody hear that? Maybe a little bit? We can try a little bit more. We can do it first, upload the file first. And it feels like angry. Let me try another one. Maybe.
Upload another one. Let's do start recording.
Upload. Yeah.
You open something. You open the mic.
Yeah.
Let's do a neutral one.
You want to do the recordings?
Let's go.
Just
Yeah.
You want to see what
That's it. No.
No?
Huh.
You want to record?
No. That's it. That's it.
That's it?
Yeah. Oh.
Okay, any questions?
It's very nice. I was surprised by the speed. You can see each time I'm uploading the audio, it's very fast getting results. What's the reason So what kind of model do you use? Why the speed is so fast? Yeah.
I couldn't tell you why it's super fast, but it just our convolutional neural network, it only had a couple layers. It was decently high in parameters, but it ended up just being kind of fast in general. Couldn't tell you why it was quite that fast. It surprised me too, but it's
Yeah, nice work. I like the demo, like the interface and stuff. Very nice.
What would it take to integrate tone into the model? Not just the content of the speech, but the tone of the speech.
I'd have to look a little more into the specifics of how audio works, but it probably wouldn't be that hard. So we used a library to convert it to spectrogram, which is a fairly easy thing. There's plenty of resources out there to do similar stuff for other different like formats of the audio. So I'm sure there's different Python libraries to extract the tone from that, and then we just have to retrain the model on that.
Where did the training data come from?
So it was a training data set on Kaggle that we found. It was called the TESS test data set. There's quite a few others like that. So in the future, we could improve the accuracy and help prevent overfitting by adding more data sets.
Does it also detect the severity of the emotion? Or right now at this phase is mainly the emotion? So if someone's angry, how angry?
Yeah.
The levels.
So right now it doesn't quite detect that just because it's working off the spectrogram, but in the background we didn't end up getting to print it out, but it detects how like sure it is that emotion. Like if it's angry, it's like 99% sure this is angry. Or if it's like not as sure, it might be a low percentage.
And actually, we also want to add more language, maybe do a multi-language support. We can include like Chinese and Arabic, something else. So improve it better. So that's what we got. Emotion TPD.
Thank you.
Everybody. Thanks for listening.
Thank you.
Good job.
Do I sum this one?
Let's go.
New studio.
You can just.
Yeah, just put it on.
She's here for your photo op, so
Thank
Thank you.
Thank you.
Oh, yeah. So tight. Thank you. Thank you.
Last but not least, wait, hello? Oh shit, does it have an adapter?
Testing.
Bro. Yeah, so you gotta plug that in. Do you have a, does this have an adapter? Yeah, and join the stream room. There's a link in Slack.
Oh, yes.
Oh.
Okay.
Where is it? That works. Where'd you send it? I didn't send it. I think y'all should have it somewhere. General?
Be loud.
Oh yeah, right there.
Con 4K.
Is the presentation on your computer?
Yeah,
okay.
on screen.
I just click allow mic access. You don't have to keep it on. You can like make yourself. Okay. Let's put some display notes. Yeah, then click enter. And then click present. Share screen. And then click on entire screen. Here, I go. Entire screen. And then allow. You can drive it. Yeah. Like what? Yeah, y'all should be good. Just like connect the.
Yep.
Once it comes up, y'all.
Yeah, okay.
You can make a drive link if it's.
All right, so we're here to share the love of music with Lovified. We want to say goodbye to superficial swipes and say hello to a harmonious matchmaking experience where we bring people together with the power of music. This is our team. We have Aiken, our mentor. I'm Suyesh.
I'm Shali.
I'm Hillary.
I'm Matt.
I'm Hania. And Shalene will get into the problem that we aim to address with our project.
So ever since the pandemic, it seems that society's been kind of moving inward, kind of being more introverted, you know? And because of that, it's become harder for us to create meaningful connections with the people around us. A lot of the apps we use these days are gonna help encourage the superficiality, like TikTok or maybe even Facebook. And so that's why we've come with a solution today, which Matt will be presenting.
Right. So our solution to the aforementioned problems, we believe, is to create social platforms around communities, around interests, topics that people are just really passionate about. And we believe we can play our small part in that bigger solution by creating a social platform specifically for music lovers. So what exactly does Lovify do? Well, here's a quick overview. We take user Spotify data with their consent, of course, and we use that data in two main AI/machine learning systems. First one is user zodiac classification. So what that basically does is we look at the user's Spotify data and we try and inference the personality traits about that user based on what they listen to. The second system is a user song similarity. So we want to match users who preferably have similar song preferences. So that system would basically just look at a user's liked songs and create a user preference profile for the type of music they listen to. And using those two metrics, we attempt to match users together as best as we can. And we also have a song recommendation system that will recommend songs to both the users once they've matched, just as a conversation starter. They can talk about music that they were both recommended. So I will now pass it off to Hillary, who will explain zodiac classification.
So I'm sure most of you who have used a social media or dating app can agree that the first and most important step is creating a profile that captures who you are. So what we wanted to do is describe users by presenting a way of, or presenting a classified summary of their music taste. And rather than using boring classifiers like mellow or energetic, we wanted to opt for a more fun classification like zodiac signs. So in order to do this, we needed to collect song data on each zodiac sign, and we used the Spotify API for that by retrieving the top 50 playlists for each zodiac sign, which got us around 20,000 rows of data. And for the user's data, we used the API to retrieve the user's top 50 most recently liked songs, the top 50 most listened to songs this past year, and the top 50 most listened to songs of all time. And for the classification model, the algorithms that we chose to try out were the support vector machine, random forest, decision tree classifier, and also a KNN classifier. And ultimately, we went with the decision tree classifier because we got the highest accuracy for it. And what a decision tree classifier does is it takes a data set and it splits it using one of the features that will provide the most information gained to the model. So in our case, it would split the items in the data set based on, say, the value of tempo, for example. And then with those subsets from that, it would split it again using a genre this time. And it would keep going until the stopping criteria for the tree has been met, such as the depth, or until there are no more features left to split the data set. So then each leaf node that you would see up here would represent each classification. And using this decision tree, we would be able to classify new data. So now here's an example of a portion of our zodiac sign data set that we got from the Spotify API. As you can see, all of these signs, or all of these songs, are classified under Aries. And before training the model with this data set, we got rid of some data that wouldn't really be relevant for our models, such as the artist name, the album name, the track ID, etc. And for the validation set, we got the top 30 rows for each zodiac sign, and we used a typical 25-75 split for the testing and training data. And after reaching the model using grid search, we were able to get an accuracy rate of 76%, meaning that 76% of the validation set was correctly classified. And here's an example of the output of our model. And what this shows is that given all the users' songs retrieved using the Spotify API, it shows that 11% of the songs were classified as being a Sagittarius song. And so I want to iterate that this doesn't classify or describe the users themselves as into a zodiac sign, but rather it summarizes their music taste in terms of zodiac signs. So for example, if someone had the highest percentage as being Libra, which is typically characterized by being outgoing, carefree, and romantic, then having a high percentage of Libra would reflect that they like more upbeat love songs. And now I'll hand over the floor to Hania so she can discuss user similarity.
Hi. So in terms of user similarity, we use the k-nearest neighbors model to calculate the distance between users by using the audio attributes of the songs. And the Spotify API is what extracts these audio features from these songs. Some of them being the loudness, the tempo, the energy, and the danceability. In terms of processing these features, what we did was we normalized them and then we used a PCA to reduce the dimensionality. And then we aggregated them into a single record, and it serves to represent the user's unique preference profile. And in terms of the model setup, we basically use the default settings from sklearn, and the results seem to be quite well, and Matt will shortly get into that too in detail. Our immediate next step is to create quantifiable performance metrics to evaluate the KNN better. And a big issue that the KNN currently has is time complexity. It currently limits how complex our aggregation function can be. And so in the future, we hope maybe we could replace this with maybe a KD or ball trees in hopes of improving the accuracy of the images. So from here on out, we know exactly what we want to do, and we seek to improve the model further. Now I will hand this to Matt, who will show the KNN model in action.
It's okay. So here's a quick demo. Before I play it, I just want to explain exactly what's happening in this video. So as we mentioned earlier, this KNN model seeks to match users with other users based on their song preferences. However, for this demonstration, I tweaked the KNN model to operate on a song-by-song basis because I think to demonstrate to the audience whether or not a user's preference matches another user's preference, it kind of takes a lot of, like I'd have to show you guys all the songs that one user likes and all the songs that the other user likes, and you guys may not know those songs. So I would just evaluate the songs themselves. So as you can see on the left side, here's the KNN that I'm running, and I'll just pause it. Oh, did I restart it? My fault. Okay, so how do I pause this? I'm sorry. Anyways, as you can see, it fetches tracks from my library, and then here, all these numbers you see are each row is a song, and each column are those attributes that we care about. So stuff like energy, danceability, loudness, tempo. So this is the data before we reduce dimensionality, and immediately afterwards. Oh, I'm so sorry. Immediately afterwards, the output from the KNN it shows. So I pass. In this demonstration, I pass song 1, and it finds the next 5 closest songs to song 1. And over there on the right-hand side, I have the songs. So I hope the audio works, so you guys can actually hear. If it doesn't, someone might need to come help me with the audio. Let's see.
Yeah, can someone come help me with the audio?
It's not on. Alright, play it. It is.
Just like go halfway through, probably.
Oh, I heard it.
Did it work? How do we get rid of the echoes?
I don't know. This is off. This. Oh, that one. Is that off? Okay, there.
Is it playing from the back?
Yep. Yep. Oh, can you turn it up, then?
What's that? What's the echo?
How's the echo? It's okay if the audio doesn't work. If you know some of these songs, like Will I See You Again by Three Sacred Souls.
No, turn that off. Don't have the stream here. Don't have the live on here. That's why that's happening. Okay.
So as you can see from that KNN output, one of the matches was song 2, which was. I'm sorry about this, guys. Okay, yeah. Yeah.
Oh, the stream yard is muted. I'm gonna do this volume. Okay. Okay. Do it. Cool.
So this is song 1. And this is song 2. And this is song 6. So I skipped a couple of songs there because there's the other songs that have profanity in them. But I think a case can be made for the 3 examples I showed you. I certainly think myself that they share a lot of similar sonic characteristics, and they definitely do belong on a playlist together in terms of like genre. So that's just a quick demo of our KNN. And
Quick question, what was the different filtering techniques? Like you showed us one filtering technique, what was that? And what was the one with the users?
sorry, can you say that again?
The filtering techniques.
As in.
Allowing the content.
Oh, so the one I just showed you, of course, is content-based filtering, right? Because we're using the user's data. And for the other models for the Zodiac, that one is also content-based because we're analyzing, the just data from Spotify. And for the recommendation system, that will be content-based as well, based on what a user typically listens to. The collaborative filtering comes in when we attempt to match users together. There you go. So with that said, oh, not this again. Yeah, I'll hand it off to Siyesh to give you the shakedown on our song recommendation system.
All right. So for our third and final part of Levify, it's our song recommendation system. So what we did is that we gathered a user's top 50 recently liked songs, or top 50 most listened to songs of this year, and the top 50 most listened to songs of all time. With this data, we fed it through our recommendation system, and we were able to create a list of recommended songs. These songs are picked from a database that we found on Kaggle of more than 600,000 unique entries, varying from genre, time period, and other unique features. There are 12 of these features, which include loudness, liveliness, tempo, and other attributes that are used to generate these recommendations. The way we do this is by pulling user data from the Spotify web API and transforming it into a single summary vector. Another process dataset is then created from the song database. The playlist summary vector is then compared to the song vector of each of the songs from the process dataset using cosine similarity. Finally, the top 10 most similar songs are returned and recommended to the user. Next, Shalene will go over our feature implementations.
So for our feature implementations, we want to expand the integration of this technology to not just Spotify, but to other platforms such as Apple Music or Tidal, or if anyone still uses Pandora. We also want to add some matchmaking capabilities, like for Tinder and Bumble. And finally, one last recommendation, or one last change we'd like to make was for our recommendation system, there really is no metric to measure how accurate the recommendations are, because I mean, it's all based on opinion, or at least user input. So we would like to add some user input functionality to the recommendation system to see whether the users like the songs that are being recommended or not, to help tweak our recommendation system.
Yeah, so that leads us into our demo. So for our demo, we are running this locally. We don't have this project completely up and running in the cloud yet, but just to demonstrate, we have a UI here, and I can sign in with my Spotify account. So let me just put in my login information. So here's me. Don't laugh, guys. It's okay. Thank you. And then, so if we have another user here, and then we log in with a different account. So on this side of things, sorry, this is, okay. You can see that using the link on the left-hand side, I've matched with, or Shailene has matched with me. And then, of course, I want to be able to see the matches as well. So I would just go over here and check my compatibility to see who has matched with me. So as you can see, our system has, well, at this moment, we're the only 2 users in the system. So of course we get matched together. But so we have been matched, and the song recommendation system has recommended us songs here that we can both talk about. And since we have Spotify integration, this works. We can play these songs. So that works. And the only thing missing in the demo is really, we wanted a chat feature where we could just go on our website and just start talking about the songs just right here on this webpage. So yeah, that is.
What are your actual signs though?
It says I am 56.8% Pisces. My actual sign is Pisces, so that ended up being pretty accurate.
Wow.
I don't know about you though.
I'm a Gemini.
Okay, here we go. Yeah, and that section, that portion of it is basically just, it helps you get to know the other person a little better. Right. So that's been our demo. Where did the presentation go? But yeah, that's all. Thank you. Yeah. Any questions, comments, concerns, feedback?
You said there's only 2 users right now?
Yes, but of course we plan to.
Yeah, 2 users at a time, right?
Or since the user matching happens with the KNN, we can match any user.
Yeah, so if I log in and each logs in, we can see if we're compatible. Just
Right.
2 at a time.
Yeah. Yes.
So what are people to like, right now, if I wanted to, I could log in.
Yes.
Yes. You'd have to come do it on this laptop.
Boys alike.
But yeah. Any other questions?
What was the purpose of using the zodiac signs?
It was just fun because a lot of traits are usually like ascribed to each zodiac signs, you know? And you see on a lot of dating apps that they'll have a little section that you can say that you're a Leo or a Gemini or something. And that's something people like to see. And rather than just doing like a boring profile, we thought it'd be fun to have that there also.
And how do you use it in classification?
So what we did is we found playlists from using the Spotify API that users had generated, which also introduced labeling bias, which I neglected to talk about during the presentation, but I'll go ahead and talk about now.
Yeah.
So what the users did is they themselves would choose however many songs and decide that these songs fit for Gemini or Leo or whatever like that, right? And we use those playlists to train our model.
So these those data come from the users?
Yes.
This is declare, this is a Gemini playlist.
Yes, exactly.
Now I understand.
So that's why it introduces labeling bias, because we don't really know how they were choosing it, right? We don't know if they were choosing it based on lyrics or just like the vibe of the song, for example.
Yeah.
So I guess going further, if we wanted to rectify that, we would have to figure out a standard way of deciding to label a song as a zodiac sign, I guess.
Yeah, where the features come from? Like the use of KNN. How did you get these kind of features?
You mean like the the attributes for like song.
Oh, yeah, attributes.
Yeah, so that comes from Spotify's web API.
Oh, okay, good.
Right. So we were just able to pull that information directly once users give us
I
access.
saw you have certain like pre-processing technique to directly process the music to get the output.
That would be nice.
Yeah, that would be nice. We can like give it. Have any raw music, let's say, from the raw music, you can add input and the model can predict, extract the attributes directly. Yeah, that can be a like additional step you can have to.
For sure. We'll definitely consider that. Thank you. Thank you guys. Oh, yes.
You think the slide, the fun slide, whoever looks the best? Or if you do the boys a liar.
By the way, I like your slides.
I know, I was gonna
Very
say,
nice.
you're
The slides.
So, yeah.
Oh, nice.
Where are we taking the picture? Oh, okay.
This is what you need in AI application. Absolutely. I wish you was got like 7:30. Quarter to 7, I'm still here. It tells you how weird.
This was the only we started last time
How do we stop things?
What?
It's recording.
Hello.
Where's the camera? Oh.